Do you want to create feature-rich, full-stack mobile applications that push the boundaries of what's possible, leave a lasting impression, and set you apart? If so, you're in the right place. Hi there, and welcome to a highly anticipated course where you'll build a full-stack Uber clone. And no, this won't be your average app showing a map on a screen. I'm talking about a 15-screen, state-of-the-art application that uses Expo's latest features, such as Expo Router, API routes, Expo Location, lightning-fast, edge-ready Postgres database, global state management with Zustand, and many others. After taking this course, you can build any mobile app you can imagine. Why? Because I didn't cut any corners when making it. I decided to include screens that appear on all the most popular apps in the world. You'll learn how to make splash screens and onboarding flows, add authentication, access device sensors, integrate maps, build custom tabs, navigation, modals, bottom sheets, success screens, and even integrate payments using Stripe. There are also some Uber-specific features you'll implement, such as live Google location with Google Maps showing nearby rides, search relocations using Google Places, choose a destination, driver, and book a ride, get directions and estimated time, see all booked rides, and your profile details. Alongside this video, in the description below, I've also prepared the ultimate React Native guide that covers everything you need to know to become a fantastic developer. The guide covers the complete React Native roadmap, prerequisites, and essential React Native concepts and project ideas you can build and deploy to get a job. You can download the guide and use it as a reference whenever you're unsure what to do next. Of course, the guide is completely free, and once again, the link is in the description. Alongside that, in this video, I'll teach you React Native fundamentals, Expo Router for file-based navigation, Zustand for global state management, Native Wind for styling, Expo API routes, Stripe payments, data fetching with custom hooks, reusable advanced components with best practices, TypeScript for writing type-safe code, ESLint and Prettier for organizing the code, authentication with email verification using Clerk, and even Postgres using Neon, a serverless, fully managed Postgres database that automatically scales resources and lets you write native SQL queries. It is so good that even Vercel uses it behind the scenes for their Vercel Postgres service. Now, with even better teaching methods, you'll get an open source codebase, a custom Figma design, and a Discord server with a dedicated Uber channel to resolve bugs if you get stuck. All those things are free, so grab those from the links below while I continue telling you more about the project. A basic to medium understanding of React Native is needed, so if you're not quite there yet, check out the React Native crash course and come right back. And we're also working on the ultimate React Native course. To learn more about it, check out the first page in the guide that I mentioned before. In this course though, I'll also teach you how to set up an IDE you didn't know you needed. WebStorm is a professional JavaScript and TypeScript IDE that'll make you so efficient you'll wonder what you were doing all this time. JetBrains reached out to sponsor this video, and initially I was skeptical about switching from the code editor I've been so used to. So I used it for over 3 months to test it for myself. And oh boy, is it powerful. I can't wait to share everything it can do. I'll do it later on while we're developing the application. But just to say it quickly, it has Smart Terminal with auto suggestions, TypeScript type suggestions, code completion, automatic bug fixes, one-click refactoring, speed search, and an integrated Git and GitHub system. And here's the best part. Clicking the link in the description will give you a free 90-day access. Plus, if you're a student, it'll remain free. Download it while I continue telling you more about the app we'll build today. When you first launch the app, a custom splash screen will appear for a few seconds. You'll then go through a smooth onboarding process, highlighting the app's main features. After that, you'll see a sign up auth screen where you can create a new account or log in. If we go to create a new account, it'll ask you for your email and password. But this time, I decided to teach you how to implement email verification too. After you enter your details, the app will request a code sent to your email. Hold on. Okay, here it is. If you try to enter anything else, of course, it won't work. Enter the right code and voila, your account is successfully verified. You can also choose to authenticate using Google, which works smoothly and logs you in within seconds. Now we are redirected to the homepage. You'll first notice a pop-up asking for location access. Once you grant permission, your location will immediately appear on the map. You'll also see the nearby drivers. If you click on them, their names will be displayed. Below is a list of all rides I've booked so far. And at the top, a Google autocomplete search bar will suggest locations as you type. Pretty cool, right? Once we select a location, we're taken to the ride finding screen, where you can enter your destination and see the location on the map through this smooth bottom sheet, which we can expand or collapse. You can also change your location and choose where you want to start by selecting places in auto-completion. Next, we move to choose a rider screen, where you can pick your preferred rider at a fair price. Then you'll be directed to the confirmation screen, where you can review the details one last time before giving any money. Thanks to Stripe, we can select from various payment methods. I'll enter some dummy details, hit pay, and watch it go through successfully. You'll see this cool modal with a smooth animation pop-up specifying that the booking is successful. We click back home to return to the home screen to see the new ride we just booked. You can also see the complete list of rides in the history screen. Plus, there's also a well-designed profile screen with all of your details. It is fully responsive and provides consistent results across all types of devices. It is such a large, feature-rich application, isn't it? And you'll learn how to build it today. So, what are you waiting for? Let's dive right in. Before we begin developing your app, I want to show you how you can set up a new IDE that I tried and loved so much that I decided to use it to replace my VS Code. I know making a switch is not easy, but just try it and you won't be disappointed. JetBrains' tools are trusted by Google, Tesla, Visa, Shopify, Citibank, and even NASA. So they'll suit us just fine. The link in the description will give you a free 90-day WebStorm license, so you have nothing to lose. Open it, fill in your information, click redeem, and follow the instructions in the email. Once you click the link you got in your email, you'll be redirected to your account dashboard and just click download. Then select your operating system and click download. Keep in mind, this is a full IDE and not just a code editor, so it's gonna take some time to download. Let's leave it be and I'll be right back. And if you're not ready to choose WebStorm yet, that's totally okay. You can still follow along with the entire video without any problems. I just want to say that I've been trying it on our internal projects for the last couple of months and found it to be the perfect IDE for web and mobile applications. I'm still discovering new features as I go, but I'm already so impressed that I won't be going back to VS Code anytime soon. Once you install it, it's going to ask you whether you want to import your settings from VS Code. So you can do that or start completely from scratch. In this case, I will import the settings. You can choose the theme, the key maps, plugins, and even the recent projects. This was super quick. And now we can create a new project. It can be just an empty project, which we can create on our desktop under /uber-clone and click create. Once you're in there, it'll look something like this. But of course, we can fully customize it. And what's the one thing that developers first change when they download a new IDE? It's gotta be the theme. So press Ctrl or Command Shift P and it'll open up this search context where you can search for theme, press enter, and then select one of the predefined themes. But of course, you can press Get More Themes and very easily install any theme you want. In this case, I'll proceed with one dark theme and press Accept. And immediately it got applied. Another thing I'll do just so you can follow along more easily is increase the font size. So I'll use the Command Shift B to go to Settings, select Font, and I will increase it to about 18 and enable ligatures. This should allow you to see much better what I'm working on. I think this is more than enough to get us going. As we develop the application, we can continue customizing the IDE to make it more your own, and I'll be pointing out to all the cool details that WebStorm does for us. So with that said, let's get started with the project setup. To develop our mobile application, of course, we'll be using React Native, a platform that allows us to learn a technology such as React once and then write code anywhere, be that Android, iOS, or web. So as we click Get Started, we'll be redirected to the Getting Started guide. And I want to point your attention to something. They say right here that you can use React Native without a framework. However, they've found that most developers benefit from using a React framework like Expo, providing you with features such as file-based routing, high-quality universal libraries, and the ability to write plugins that modify native code without having to manage native files. So we'll use the recommended approach and we'll start a new React Native project with Expo. We can do that by quickly navigating over to their page and going to the docs. To get started with it, there's only one command we need to run: npx create expo app at latest. So if we copy it and go back to our code editor, you can open up the terminal by holding the control and then the key left of the one key on your keyboard. And yeah, terminal is a whole other beast in WebStorm. As we write commands, I'll point out some cool features that it has. So right here, we can run npx create expo app at latest and then add the / at the end to create it in the current Uber clone repository. Let's press enter and press Y to install the following packages. Let's give it a moment until it does its thing. And while the packages are getting installed, let's set up the database which we'll use to make our entire Uber application possible. We need to have a place to store user accounts, the riders, the drivers, and the rides themselves. So click the neon link down in the description to be able to follow along and see exactly what I'm seeing. Next, click Get Started and sign up. I'll continue with Google. For this project, we're not using any third-party libraries for our database management. You'll be working with a native Postgres database and will write real SQL queries. Here, you can enter your project name, started with JSM_, and then you can enter your project name. You can do Ride or Uber or whatever you prefer. And same thing for the database name, I'll do JSM Ride. You can choose the region that is closest to you and click Create Project. And there we go. We are redirected to this beautiful dashboard, which we'll put to full use soon enough. There we go. It took some time, but it finally worked. Your project is ready. And now we can either run Android, iOS, or web. Before we do that, you can press these 3 dots here and enable the new terminal, which is in beta right now. And soon you'll see some of the new functionalities that it brings to the table. For now, let's just type npm start and press enter. You will see some warnings right here, but that's not a big deal because below that, you will see a QR code that you can scan with your phone. And this QR code is very important for the whole Expo React Native environment. If you don't want to use it, there's some different alternative options that we can use, such as pressing A to open up Android Studio or the letter I to open up the iOS simulator. But for all of these things, you have to have heavy software. We all know those stories where you open up Android Studio and your device starts heating up and explodes. And for the iOS, it doesn't explode, but you have to have very expensive devices. What Expo allows us to do is to use the Expo Go application to run our application on our phone in real time and see exactly what we're developing. And we can even play with it and touch the app in real time. That is super cool. So let's go back to this QR code. And if you're an iOS, you'll have to scan it with your camera. And before you scan it, you'll have to go to your App Store or Google Play Store and just download the Expo Go application. It should look something like this on your phone. So I think this is the perfect time that I brought my phone preview on the right side of the screen. So at all times while watching this video, you'll be able to see exactly what I'm seeing on my phone screen. So once you download it, simply click Open. And you'll also have to create your Expo account by logging in. If you're on Android, you can open up the Expo Go app and scan the code from there. And if you're on iOS, you can scan it directly from your native camera app. And on both systems, make sure that you're connected to the same Wi-Fi network where you're running the code. So both the phone and the device have to be on the same network. And on iOS, you'll also have to go to your phone settings, Expo Go app, and turn on the local network. And also turn the VPN status off to not connected. This is necessary for Expo to connect properly. Then open up your phone camera, point it at your QR code, and click Open in Expo Go. But it seems like there's an error here. It says too many open files, error, node watcher broke, and then it exited. So we of course cannot test our application if we're no longer running the Expo server. Since it points to the node watcher instance, I think our Node version might have something to do with this. So let's just go to the Node.js website and click Download Node.js LTS. This is the long-term support version. Once it gets downloaded, simply follow the steps to install it. To check whether our newly installed version of Node applied, we can type node-v. And unfortunately, it's still using a newer experimental Node version for me. And for you, it might be something else, but maybe not the one that we just installed. For that reason, we can use a package called NVM that is a version manager for Node.js. There's a handy GitHub repo that allows us to install it and update it with one script command. You can use curl on macOS or wget on Windows. So let's copy the command for your own operating system and paste it in the terminal. It'll quickly install NVM, and you need to close and reopen your terminal. So let's close this one and reopen it. To verify the installation, you can run command-v nvm, which should output NVM if the installation was successful. And now you can install a specific version of Node. I believe the active version at the time of the recording of this video is version 2016. So we can say nvm install 2016.0 and press enter. There we go. And now we can type node-v to check your current Node version. Now let's rerun npm start to see whether now Node Watcher will properly watch over our Expo application. I'll scan the code one more time with my device and open in Expo Go. It seems like the application is building. You can see that right here. iOS has been bundled, and we can see the welcome screen. Success. So now we know that we might want to use the stable versions of Node when running your Expo applications. Great. But with that said, I mean, just look at this. We have successfully set up a React Native application, and right now, I have my phone in my hand, and I can swipe around, move through different screens, and even open up some toggles that tell me a bit more about the Expo's functionalities. We already have a working Expo application. But of course, today, you will turn what you see on the screen right now and what you're holding in your hand into what I believe is one of the most popular mobile apps of all time, Uber. So let's continue with doing just that. And since this will be a pretty big application, you know that every big app needs to have a proper setup. We need to ensure that the app is scalable and the code is readable. So for that reason, let's go ahead and set up a couple of things that'll make our development experience so much better. First, we'll install Nativewind. Nativewind is a React Native version of Tailwind CSS that allows us to very quickly write styles within our mobile applications. So let's just head over to the Expo Quick Start and install Nativewind by running npm install Nativewind and then installing Tailwind CSS as well. We can copy this command, go back to WebStorm, and run this command. Now we can see that our terminal is currently running the Expo Go application, so we can just open up a new one right here and paste these commands. We can quickly head over to our package.json. I used a command P shortcut to quickly open up my file manager, and we can scroll down to dependencies and search for Tailwind CSS as a dev dependency, as well as a Nativewind installed right here as a regular dependency. Next, we need to set up Tailwind CSS by running npx Tailwind CSS init. So let's open up the terminal and paste this command here. By the way, I want to point your attention to how WebStorm terminal dynamically separates each command from each other, so you know exactly what you're working on. Here we have the one that we just ran, and below we can run a new one. There we go. This just created a new file, and it's asking us whether we want to automatically add it to Git. Sure, we can add it. And now we can check out our new tailwind.config.js, and we can copy this code from the Nativewind installation and paste it right here. But of course, we'll have to modify it to make sure the content is all right. There we go. Step 3 is to add the Nativewind Babel plugin under Babel config.js. So let's navigate over to Babel config.js. One more time, I am using the command or control P to open up the file explorer, which is the quickest way to move over the files. But of course, you can just open up the project by pressing the command Shift and E or clicking right here and then finding the Babel config. Now I will add the plugins, Nativewind Babel. And that's it. We can start writing code. Before we test it out, we need to do one more thing, and that is make TypeScript work with our Nativewind. So the only thing we have to do is create a new nativewind-env.d.ts file in the root of our directory. So we can do that right here by creating a new file and pasting this name. And then we can add this reference right within it. And now TypeScript will know exactly what we're doing with the styles. To test it out, we can copy this view right here from the example code and go to our app, tabs, and then index.tsx. As you can see here right now, it says welcome and all of this other text. We don't necessarily need that. We just need one single view to start understanding how we can modify the code that has been provided to us. So I'll just use one single view. By the way, a view in React Native is similar to a div in web development. So let's import this view from React Native at the top by saying import view, as well as a text and a status bar from React Native. And we don't need any of the other imports. We can also remove all the other styles that we had in there. Now, to test whether it works, we have to position our text to appear in the middle of the screen. And in React Native, we do that with something called a safe area view. And there's an additional package that we can install that provides that component right out of the box. So we can run npm install react-native-safe-area-context and press enter. As soon as it installs, and it'll do so quickly because it's a very small package, we can now import something known as a safe area view coming from React safe area context. And instead of using the regular view, we can wrap our app with a safe area view. Now you can see that the text fits nicely at the top of the screen. Now, even though the text is in view, the styles are still not getting applied. And we can see that because the text should be centered, but it's still appearing at the top. So we can go over our tailwind.config.js and we can quickly modify the content. We need to tell it where we will be writing styles so that it starts understanding them. So instead of a capital A for app, we can say /app /**, meaning everything in those folders within the app, /*, and then we have those file extensions. And here, instead of a custom directory, we have to modify this to say /components /**. And now if we go back, you'll see that the text is centered. We can also give it a class name equal to something like text-red-500 to see that it changes color. Now, it is highly likely that this will not be working for you immediately. There's just a bit of an annoying thing that we sometimes have to do with Expo applications whenever we make any big changes, such as install Nativewind or any other major packages. And that is clear the cache, okay? Remember this, clear cache if something doesn't work. So for you, what you can do is stop the server from running, clear it, and then run npx expo start-c. This will run it with a cleared cache. So if you rerun the project, you can see it right here. It says bundler cache is empty, rebuilding, and then you can press R while in terminal to reload your application. After you do this, I'm pretty positive that it should work. And there we go. Our text is in the middle, and we can say something like Uber clone. We're getting ready to start building it. Now, Uber is a big application. And as I've told you already, when you're starting to develop big applications, there is a bit of a setup work that you have to do to make sure that the rest of the building process flows smoothly. And one of the things that is very important to set up in big projects is a linter. In our case, we'll use Expo's recommended ESLint and Prettier configuration. So let's just follow the steps. We can run npx expo lint. I'll do it in our second terminal, not to disturb our application. It's going to ask us a couple of questions, such as, do you want to install ESLint in this project? And I'm going to say why for yes. Let's give it some time, and I'll be right back. There we go. ESLint has been configured. We also need to install Prettier. So let's scroll down, and I think somewhere here we can see the installation command. So let's copy it and paste it in the terminal. That was simple. And now we have to update our ESLint RC file with the following code. So let's head over to ESLint-rc.js and paste this code right in. Now, ESLint and Prettier will be watching over our changes and make sure that we write quality code. In WebStorm, there's one additional thing that we have to do to properly set up ESLint. So press Command-Shift-B or Control-Shift-B and type ESLint. Open up its preferences and head over to manual ESLint configuration. Click on this arrow right here, and then choose the ESLint for our specific Uber project, and select Run ESLint Fix on Save. Click Apply, and also head to Tools, Actions on Save, and make sure that it is turned on. We can repeat the same thing with Prettier by going to Settings, Manual Prettier Configuration, and then choosing our own config right here, and Run on Save. Apply, and OK. That's it. You can see how immediately Prettier changes our configuration to be easier on the eyes. And it works so seamlessly with WebStorm. And if you're using some other code editor, here's the settings.json file which you can put in there to also make it work there. The code available to copy is in the GitHub README linked below. And now that we have linting set up, let's customize WebStorm even further to make it truly our own. I'm gonna press Command-Shift-P or Control-Shift-P on Windows, and I'll go ahead and change the theme. You can scroll down and go to Get More Themes, and many of you have been asking me what theme do I use, and now I can finally tell you. It's going to be a Cat Puchin theme. You can type it like this, and you can just go to search in the marketplace. It's spelled with a double P and double C. You can install it, and once you do, you can go to Theme and change it to Cat Puchin, and then choose the flavor you prefer, macchiato or mocha. Once you have that, I'm gonna also do another thing, and that is change the font family. So you can search for font, go to Preferences, and then go to General, Editor, Settings, Font. And here I chose Fira Code. This is the font that I've been using for a long time. You can also choose that one, and you can install it by simply downloading the font to your device. Another thing I want to focus on is to turn on something called Soft Wrap. So go to Configure Soft Wraps, make sure to add the *.tsx and then semicolon *.jsx files here so that it wraps for those files, and turn off the use the original line indent for wrapped fragments. That's going to allow us to wrap specific files. It should look something like this, so that once the text goes beyond the line, you can still see it on the screen right here to make it easier for you to follow what I'm doing. And another thing we can do is install a material theme for our icons and folders to make them look just a bit better. So once again, Command-Shift-P, search for plugins, go to Marketplace, and search for icons. You can choose the Atom material icons or anything else that you prefer. In this case, I'll go with Atom, click Install, Apply, and OK. And we do need to restart our IDE for the changes to be applied. Once you're restarted, you can notice that now all of the folders have their corresponding icons, which makes it look so much better. Also, you can see that the colors change for some of the icons on the side. For now, what I want to do is clean up this environment a bit, so we can just hide some of the things right here that we don't need to create a bit more space for us. We can customize the toolbar, remove the part from the center, and also remove some of the parts from the right, as we don't necessarily need to play with the toolbar, play with the code with me. We don't need anything on the right, so I will remove that as well, and this will clean it up just a bit. You can do the same thing for the things at the bottom that you don't necessarily need. And there we go, I went ahead and I hided some of the things from the screen. Now we have a cleaner working environment. With that said, we can now proceed with cleaning up our file and folder structure now that we can see it a bit clearer. When we initially set up our React Native Expo application, it came with a lot of different things. The file and folder structure already set up, 2 different pages. There's a lot of stuff that we don't necessarily need, and that will just complicate your understanding of our React Native application. So I want to make sure to take a second to delete all of the things that we don't need to focus on creating everything from scratch. Right now, our application is not running, and maybe for the better. That's because we are going to do a whole cleanup and then we're going to run it together later on. So first things first, let's delete the things that we don't need. I'll begin with deleting the tabs route group by simply clicking delete or pressing the backspace key and pressing delete. Next, I'll delete the hooks folder as we don't need it. I'll also delete the constants folder and the components folder, as well as the assets folder. So we're going to clean our entire application up. We only have our HTML index.tsx, and you might be wondering, what is this HTML file? Well, Expo allows you to run your applications in the browser as well, but that's not what we need to be concerned with at this point in time. There's also a 404 page that can show up if we are on a not found screen. But again, not something that is super important right now. What we do want to focus on instead is the layout.tsx file. We want to update it a bit to suit our very minimalistic app right now that doesn't have any additional files. Inside of here, you'll notice we have a theme provider. For now, I will go ahead and delete it. And the only thing we'll have is the stack, a stack of different screens. The name of our first screen will be just index. It's our home. And under options, we'll run header shown as false. We also have a screen for the not found. And this is the only thing we want to have for now, just an empty screen. Next, we can create that index screen right here in the root of our directory. So let's go to app and let's create a new file called index.tsx. Within it, we can create a new homepage by saying const home is equal to, and we're going to create a new arrow function component. And let's not forget to export default that home component at the bottom. Within it, we can return something. Within it, we can import a view, which is going to come from React Native. And we can show a text, also coming from React Native. And it can say something like home for now. You can notice that WebStorm sometimes adds these additional inlay hints that allow us to see where we're using specific instances of our code. They're going to be super useful later on when they tell you more information about different parameters within the functions. But in this case, I don't need them to show the usages. I can hide code vision usages in line hints, not all, and this is just going to provide us with a bit of a cleaner working environment. Now is the time that we reopen our terminal and rerun npm start, just to see if our application still works after making all of those changes. We can press R to reload our application, and you'll see that we have an issue in our notfound.tsx, which makes sense because we changed so many things. I pressed Command P or Control P to open up the file search, and if I start typing, you can very quickly just press Enter and navigate to that different file. Here you can see that we used two different components, which we no longer have, so we can just remove their imports. And we can also just, instead of a themed view, just say view coming from React Native. And instead of theme text, we can just say text coming from React Native as well. There we go. If we save it, we should have no more issues with the code. But our app still doesn't seem to be there. Well, that's because this view doesn't have any styles, and most likely the text is being pushed above our application. So we can use a safe area view coming from React Native, or in this case, we have a special package React Native safe area context as well, but it's still not showing. So if I open up my terminal, we can see that the iOS bundling failed, and it's still complaining about the component's theme text, even though we deleted it from the not found screen. So what we can do is press R once again to reload our application once more. Now it's complaining about hooks use color scheme from app layout. So we can go within it. We can remove everything that we're no longer using just to simplify it alongside the use color context. And we can also remove this color scheme from here. And if we scroll down, we can see that the stack screen is okay and we're not using anything regarding what we just deleted. So I think we're good now. I'll just reload one more time. And now it's complaining about a splash screen, okay, in the app.config.js because we removed our assets. This is completely normal. We removed a lot of code, so we have to make sure that it all works. So in this case, I'll provide you with the full assets for this entire project. In the description down below, you can find an Uber repository with the entire codebase for this project. But what's even more important is that right there, you can find the entire README for this project. And one of the things in the README are the snippets and the assets. In this case, you can download the assets for this project. This includes the illustrations, the icons, and all the little images that we'll be showing on the app to make the development of our app easier. So let's click here, and you can just press the download button. Once you download them, simply unzip them, and then drag and drop them to the folder where you have your app. For us, it's on desktop, and it's within the Uber clone. So now if we go here, you can see the full assets of our application. WebStorm also asked me whether I want to add it to Git, so we can say sure. And here we have all of the images. So that means that now we can go to the app.json and we can modify some important information about our app. For example, we can choose the name as Uber with a capital U and a slug of Uber. Here, it's taking the icon directly from the assets images icon.png, and it's taking a splash screen directly from our assets as well. We can leave the rest as it is. Now, if we try to reload our application once more, you can see that a new splash screen that says Ride appears right here. So if we reload it once more, you can see how nice it looks like. A splash screen on mobile devices is a screen that appears before your application loads. It gives the user something to look at while it's loading. Now we have issues with the fonts because we won't be using the regular Space Mono font. Rather, we'll be using a different one. We'll be using Plus Jakarta Sans. So we can head over to our app and then head over to layout.tsx to modify the fonts we're using. These fonts just need to be copied, and you can find them under the snippets in this GitHub repo. You can find root layout fonts, copy this block of code, go back here, and then simply paste them. I'll zoom this out a bit so you can see it better. Make sure that it is formatted well. I believe it already should be for you. If you still see some issues in your terminal, you might want to press Ctrl+C to exit, and then you can run npm start once again, and then it should build it properly after pressing the R key on your keyboard. You can see the splash screen while it's loading, and then after that, you can just see the home. And that home is exactly what we have crafted in our index.tsx. So this is perfect. Now we have a structure that we're starting to understand. We have an app where we have a not found page, we have a layout and an index, and we have also learned how to add a splash screen to our React application through app.json. It is as simple as pointing to an image that you want to show. So let me show you. It's assets, images, splash. If we go to assets, images, and then splash, this image is right here. Perfect. With that in mind, we are ready to set up the styling for our application that we'll use throughout this project. We can start by navigating over to tailwind.config.js. In that same GitHub repo, you can find the modified Tailwind config.js that extends all of these fonts and ensures we can very easily use them. So just override the existing Tailwind config. You'll notice that here we also import some of the different variants of colors, such as primary, secondary, success, danger, and warning, so that we can use them within our application. Nothing more, nothing less. So what do you say? With all of that setup out of the way, are you ready to start creating the onboarding screens of our application? Finally, some real code, right? We already have this splash screen, and now we're starting with the first out of 3 onboarding screens. And I would highly recommend that you replicate this Figma design as well. The link is going to be down in the description. You can easily get it, and that way, at every point in time, you will know exactly what we're building. So get that Figma design, and let's start by creating our first onboarding screen. Within the app folder, we'll create a new route group by creating a new directory, and I'll call it root within parentheses, like this. Within the root, we'll create a new underscore layout. Yes, each route group will have its own layout depending on what is it showing on the screen, because our onboarding screens won't have the bottom bar, which means that we have to have a separate layout from the rest of the screens. Then within the root, we can create another directory, which will be called tabs. So these are the tabs that we can switch between, and here we're gonna have some of the primary pages of our application. It'll also have its own underscore layout.tsx, and it'll have a few other files, such as the homepage, the profile, and more. So what do you say that we create them right away by creating like a home.tsx file? And within it, we can just create a simple React arrow function component. Const home is equal to basically an arrow function component that returns a view with a text. We already have that, right? It is currently within the primary index.tsx. So let's copy it and paste it into home. We can now copy this and create a few other files as well within the tabs folder. It'll be a new profile.tsx where we can paste everything we have here and rename home to profile. We can do the same thing for chat.tsx and rename it to chat. And we can do the same thing for history. So this is going to be a history of a rides that we have. History.tsx. We can paste it and call it history. I think we can rename it to something like rides. It would make a bit more sense. So let's just do rides.tsx. And there we go. It automatically renamed it here as well. Perfect. So now we can start seeing how our application will look like. And it's very important to mention here that what you're seeing right now is Expo Router. It is a file-based router for React Native applications, allowing you to manage the navigation between the screens in your application so you can move seamlessly between different parts of your app's UI using the same components on multiple platforms. What I love about it is that it's using the same file-based routing concept from web, specifically Next.js. So if you've done some Next.js apps, it's gonna feel like home. So how exactly does it work? Well, Expo Router uses links to move between pages in the app. It's similar to an anchor tag or href attribute, where you have an app, you have an index page, about page, and you can have subpages or even dynamic pages. And then you can use links to move to different pages, or use buttons. We can also use the navigate functionality, which behaves similarly to modifying the URL in the browser. And the primary way of navigating in Expo applications is the Stack Navigator. It is like a navigation bar in the browser. You first need to create a file-based routing structure, like with an app, a layout, and then some additional routes. And then in the layout, you can create something known as a stack of screens. Each screen can decide to show or hide the header styles, can have different colors and more. And then you can configure how do you get to each one of these screens by giving them a name. So let's create a stack of our own. We use the stack to modify how a specific route behaves. So if we go right here to our route layout, you can see that we have this index route, which is our homepage. And there we have added an option of header shown to false. If we remove that option, you will be able to see the name of the route, which typically you don't want to show. So that's the reason why we have to add all of these stacked screens, only so we can add options. Header shown is set to false. And we're going to repeat this process for all the other routes and route groups. So we're going to do the same for the route. So that's the route route group, header shown false. And we're going to do the same for auth. This is a second group of routes, which we'll show. So let's go here, and next to route, which is going to be the primary part of our application where we're going to have all the routes, we're going to have something that happens before we enter the main application, which is the onboarding and the auth. So let's create a new directory called auth in parentheses. There, we can also create a new _layout.tsx, and within it, we can duplicate the main layout we have right now, but we'll remove some of the things regarding the fonts. We're loading the fonts once, we don't need to load them anymore. So it's going to be much simpler. It's going to look something like this. Import stack from Expo Router. Then we can declare a layout, and a simpler way to do it is const layout is equal to an arrow function. And then we can just export default it at the bottom by saying export default layout. And here we have different stacks of screens for that route group. So no longer do we have to have the index or the route or the not found. Rather, we're just going to have the welcome, which is going to be the primary screen. And then we're going to have sign up. And finally, we're going to have the sign in. And we want to hide the headers in all places. So that means that we have to create these additional auth pages, such as welcome, sign in, and sign up. Let's create all three. I'll create a new file called sign-in.tsx, and within it, we can paste just the basic component which we created in our index.tsx. So that's just going to be a basic view, safe area view with a text that's going to say sign in. We can duplicate that once more by creating a second file in the auth group, which is going to be called sign-up. home.tsx, and we can rename that to sign up. We can also rename the actual component name, sign up, single word. And we can do the same thing for the sign in, since I forgot to do it there, sign in. And finally, we need to create one last auth page, which is going to be the first one we'll start to work on, and that is the welcome onboarding. So welcome.tsx, where we can paste it and say onboarding. Great. So now the question is, how can we navigate to this page right here? Right now, our app is saying home because we have this index.tsx that is rendering the home. Well, in here, we'll do a simple redirect in case we're logged in. So the return will do only one thing, and that's going to be call to a redirect component coming from Expo router with an href of / route group of auth / welcome. Now, as soon as somebody opens up the application, we'll be redirected to, oops, the screen doesn't exist. Okay, we know that at least the 404 is working as well. Let me do a reload by pressing R right here, and you can see that now it worked. Sometimes while developing React Native applications, you'll have to reload your application often. And now we are on the onboarding screen. We also have a warning right here at the bottom, but you can just collapse it to close it right now. We can close all of the currently open files and just head over to our welcome screen, which is really an onboarding. And the pages for the onboarding are going to look like this. It's going to be a 3-page or 3-step onboarding process where we'll have some nice illustration, a title, description, tabs that move as we move to the second screen, and then the button that says next. So let's get started with creating our first real piece of user interface in a large React Native application. There's one small thing that I can see here, and that is that we have 1 week warning pointed out by our WebStorm. In this case, this is not a real warning because if you think about it, it says unused default export, but we're actually using a file-based routing system, so we never actually have to import the onboarding. It is just being used by default once we go to that page. So to hide this error, you can press Command or Control-Shift-B and type inspections, and then search for unused global symbol and tick it off. Click OK, and then close and reopen your WebStorm. If you do that, you can run npm start one more time, and the error will be gone. Great. Another thing you can do to clean up your workspace is go to Toolbar and then toggle it off. I don't think I need all that info at the top, and this just makes it so much easier for you to follow along. And with that in mind, we can now dive right into the onboarding. I'll press R to bundle our app one more time. So press this warning and we can get started. Everything is already wrapped in a safe area view coming from React Native safe area context, which is why we can see the onboarding text right within our screen. Next, we can give our safe area view some class names, such as a class name is equal to flex, h-full to give it a full height, items-center, justify-between, and bg-white. So now this will center the text horizontally. Next, instead of this text, right within the safe area view, we'll create our first touchable opacity, and we'll import it from React Native. In the React Native or mobile world, a touchable opacity is basically just a button. You know how on web you have a button, here on mobile you have a touchable opacity, within which we will render a text coming from React Native, and this text will say something like skip. So in case we want to skip this onboarding, we can do that. What's going to happen if we decide to skip it? Well, instead of on click, here we have an on press activity, and on press, we can call a callback function and say something like router.replace. And we want to go over to /auth /sign-up, just like this. And this router will be coming from Expo router. So we can say import router coming from Expo router. Great. Now we can also give a class name to this touchable opacity, and that's going to be a wfull, so full width, flex, justify-end, items-end, and a padding of 5. So we show it a little button at the top right. We can also style this text element by giving it a class name, which is equal to, let's do text-black, text-MD for medium, and font-Jakarta bold. So this is one of the fonts that we imported. It didn't seem to apply the bold style, so I think we should use the capital J. There we go, Jakarta bold. This now works. Great. Now let's go below this touchable opacity and let's create a component that allows us to swipe left and right like we're in Tinder, but we're not swiping different dates, we're swiping the onboarding cards. Almost as exciting, right? So for that, we'll install a new component in the new terminal, npm install react-native-swiper. And we can use it right below the touchable opacity by saying swiper, and we can import it at the top by saying import swiper coming from react-native-swiper. Currently, this will break our application because swiper expects to have some things within it. So let's add it. First of all, we have to create a new reference to this swiper so that we can control it. We can do that by saying const swiper ref is equal to use ref of a type swiper, and at the start, it can be set to null. Next, we can just say ref is equal to swiper ref on this swiper. We can also give it a couple of other properties, such as a loop. In this case, we don't want to loop over the swiper. We just want it to come to the end after the 3. So we'll set the loop property to false. It also allows us to change how the dots look like. So the dot for the first swipe, second, and the third. So we can say dot is equal to a view, which remember is a div in a mobile world. And we can make it self-closing and give it a class name equal to w-32 pixels within square brackets, h-4 pixels, margin x of 1, and bg of a very light variant of a white color. So that's going to be E2, E8, F0. And we of course have to import the view from React Native. And we also have to import useRef inside of square brackets from React. Now this is a very cool thing about WebStorm. As soon as we imported this useRef, we no longer have to hover over it to see what it does. You can see that it understood that this null that we passed is a property that specifies the initial value. Similar thing here, it recognized that the first prop or the first parameter to this function that we're passing is corresponding to an href property. So now as you're typing, you can immediately know what you need to pass in it. Sure, you could hover over it and see what it is, but it is so convenient to just start typing something and then immediately know that that's corresponding to an href in that specific method. Great. So now we created this swiper and explained how a dot should look like. We can also duplicate this dot and change it to an active dot. So depending on which screen we're currently on, and here we're going to change the BG color to something like 028 6FF. And we're going to make it rounded by saying rounded-full. As a matter of fact, we can do that for the dot, regular dot as well. Great. And somehow we have to keep track of the indexes that we're switching from and to. So we can create a new use state, call it active index, set active index, at the start set to 0. And then we can handle that with the onIndexChanged property, which will accept a callback function with the new index. And we can simply set active index to be equal to the index that we have right here. Finally, we can show something within that swiper. And sure, what you could do is create an array of things right here that's going to have different objects, where each object will have something like a title, it'll have an image and description. And if you did this quickly, your JSX file, or in this case TSX, would grow, and then you would have to map over them. But typically, you don't want to combine the presentation, which is the JSX or the TSX in this case, with the data. So the data of what we will be showing. So for that reason, it's always good to separate some of these pieces in specialized files. In this case, I'll create a new directory or folder called constants. And within it, I'll create a new file called index.ts. Here, we can create a new onboarding array, which will contain 3 different objects for 3 different screens that we have. Each one will have an ID. It'll also have a title, something like "The perfect ride is just a tap away." And we can also have a description, something like "The journey begins with ride." And we need an image to show. So for now, I'll leave image to null. And now we can do the same thing for all of the other onboarding fields. And of course, let's just export this as well by saying export const onboarding. Now within here, we can use this onboarding coming from the index.tsx file and map over it by saying .map, where we get each individual item. And for each one of those items, we want to render a new view. For now, let's simply show the item.title. And it's pretty cool how it immediately knows how these properties look like. So we can just say this. And it's not showing on the screen right now. And that's because we cannot just show a text inside of a view in React Native. In React Native, you have to wrap it in a text property. So let's import text from React Native and also close it up with a text property. If we save this, you can see the perfect ride is just a tap away. And soon enough, we'll be able to swipe that left and right to move to the next screen. And if you accidentally go to sign up, you can just press R to reload and rebundle the application. Great. Now, alongside this, we want to show an image from Figma. And sure, you could go here and download it, but thankfully, we already have it in the assets. So the only thing you have to do here in the constants is refer to images.onboarding1. But of course, we have to have the path to that image. So we'll have to do something like import onboarding1 from add/assets/images/onboarding1.png. And now we'll have this onboarding1 image that we can show. But we'll have to do this for importing every single image, every single icon, and everything else. So for that reason, just to simplify the procedure a bit more, I have added the entire constants index.ts where I'm simply importing all of those images and then exporting them where we need them. That way, it's going to be much simpler to just continue with development when our data is nicely structured and we can easily import it. So copy this file and then override the entire index.ts of constants. You'll notice that here we have the entire onboarding, we have some icons, and we have all of these assets. It's currently saying that it cannot find the type declarations for these things. So we have to add the type declarations for these images just so that it recognizes it. So copy this first file and create a new typed.ts. That's going to be in the root of the directory. New folder called types. And then within it, we can create a new file called type.d.ts. And we need another one, which is type image.d.ts, where we can paste this. So create a new file, image.d.ts, and paste the declarations for the images. Now, if we go back, it's no longer complaining. Great. And now if we just reload one more time, you can still see the perfect ride is just a type away, but now you can move between different onboarding profiles. That is perfect. And of course, if you want to, you can completely change the titles for each one. For now, just the images are changing, which is great. So let's show that image so we can actually see the difference and swipe between these 3 different screens. To this view, I'll provide a class name equal to flex items-center, justify-center, and a padding of 5. Since we're mapping over it, I'll also give it a key equal to item.id. And right within the view, above the text, we'll render an image coming from React Native. It'll be a self-closing component with a source equal to item.image. So it's coming from constants. A class name equal to w-full and h-300 pixels. And we'll also give it a resize mode equal to contain. So now you can see how we have this nice looking image and we can swipe between these 3 images. This is super cool because swiping is not something you can do on desktop devices, but on mobile, it feels so natural to move it with your finger. Right below this image, we can render a view. Once again, it's like a div in React. This view can have a class name equal to flex, flex-row, items-center, justify-center, w-full, and a margin top of 10. So we're just centering everything. Within it, we can render a text element that'll have a class name equal to text-black, text-3XL to make it very large, font-bold, margin X of 10, and text-center. Within it, we can simply render the item.title. The perfect ride is just a step away. We can go below this view and below the text and create another text. This text will render the description. So we can immediately say item.description, and we can give it a class name equal to text-md, font-jakarta, semi-bold, text-center, text-hash 858585, margin X of 10 to divide it from the left and right side, and a margin top of 3 to divide it from the title. And there we go. Your perfect ride is just one step away. In this case, we can make this text-lg just so it's a bit larger. There we go. And we can finally create a custom button that should go below here that says next. Sure, we can swipe, but if the user is not used to the swiper, we can also have just a button. So let's create our first custom component of the day. We're going to create a new components folder right here in the Uber clone called components. And I'll create a new file called custom button.tsx. Here we can create a const custom button, which is going to be a React arrow function component, and it'll have an immediate return. So we can just wrap it in parentheses, and at the bottom we can export default the custom button. So this custom button will of course return the touchable opacity, because the touchable opacity is a button in React Native. Every touchable opacity needs to have an on-press functionality. And in this case, since it's a custom button, what this button will be doing will be coming through props. So we can simply pass the on-press from props and then call it right here. It'll also have many other things in the props. So let's destructure them. We'll have a dynamic title. We'll have a BG variant, which by default can be set to primary. We'll also have a text variant of the button, which by default can be set to default. We're going to have an icon left with a capital I and an icon right if we need to provide it to the button. We're also going to have some custom class names. And finally, we can spread all the other props in case we need to share it with the button. And you can see how convenient this is right now that Prettier and ESLint automatically reformatted my application so we can better see what's happening. Within this touchable opacity, I'll say if there is an icon left, then we can render that icon left component, just like so. I'll repeat that at the bottom and say if there is an icon right, we'll render the icon right. And make sure to say left right here. In the middle, we'll show the actual text of the button. So this is a text coming from React Native, and it'll render the title that we're passing as a prop to this button. Now let's import this custom button at the bottom of the swiper. We can do that by declaring a custom button. It'll be a self-closing component, and we need to pass some of these props, such as a title. And the title will say something like, next. We want to go to the next screen. Immediately, you can see the next key appear right below the swiper. We can also give it some class names, such as W11 out of 12 and margin top of 10. And now we can dive into the button and style it further by giving this touchable opacity a class name, which will be a dynamic template string of W-full, rounded-full, flex, flex-row, justify-center, items-center, shadow-md, shadow-neutral, -400 over 70, and we can then dynamically call get bg variant style. And to it, we can pass the bg variant just like so. And finally, we can render the class name dynamically right here as well. But what is this get BG variant style? Well, it's a utility function which we can create right here above by saying const get BG variant style is equal to, it obviously accepts a variant which is of a type button props, which we can import from types, of a BG variant. So it can either be primary or secondary, and we'll open up a switch statement where we'll look into the variant of that button, and depending on the variant, if the case is, for example, secondary, we'll apply a specific color, such as return BG gray 500. And now we can cover it for all other cases. So I'll duplicate this a couple more times and say if case is danger, then the color will obviously be red 500. If it's success, then it'll be green 500. And if it is outline, then we'll make it transparent by saying BG transparent border dash neutral dash 300 and border dash 0.5 pixels, and we can close it. Finally, if the case is the default case, so we can say default, then I'll return a BG of hash 0286FF, which is some kind of a basic button color. Great. So now we can see that this button is taking a BG variant of primary in this case. And I believe that is the default color here. In this case, it looks like it's complaining a bit. It says that the BG variant needs to be of one of these types. And what are we passing? It's BG variant primary. And here we're not passing anything as the BG variant. So I do believe that we should be good. But it thinks that it is just a string. And we know that it's always going to be of one of these types. So we can say here that a BG variant will be of a type button props, coming from the types declaration. This way, we're importing this declaration where we say that the BG variant will always be of one of these types. Great. So now we can also style the text by giving it a class name equal to text-lg font-bold, and we'll also do a very similar thing that we have done with the backgrounds. So I will make this a template string. And instead of saying get BG variant, I'll say dynamic get text variant style. And then to it, I'll pass the text variant. So now we have to declare this function right above, and I'll do it by duplicating the get BG variant. And I'll say get text variant style. And it's gonna be of text variant. Right here, we have the primary, which will just make the text black. So we can say text-black. Next, we can move this outline a bit above, below the primary, and we'll call that a secondary. And this one will simply say text-gray-100. Next, we have danger, which is going to be a text-red-100. And finally, success is going to be a text of green 100, and the default will be a text of white. So now we have those two helper functions that are going to help us determine what kind of variant styles we want for our button. And of course, all of this in order to make it easier to add new buttons in the future. We did some heavy lifting to make this button fully customizable, but now the next time that we use it, it's going to be super simple. Now, let's make that button do something. First, we have to figure out if we're on the last slide or not. If we're not on the last slide, we simply want to move to the next screen once we click it. So right at the top, let's use the active index to figure out on which screen we're on. We can create a new variable called isLastSlide and say if active index is triple equal to onboarding.length -1. So if we're on the last screen, that must mean that we're on the last slide. Depending on that, we can change some different things, such as we can change the title. We can say if isLastSlide say get started, else say next. Similarly, we can change the onPress button action by creating a new callback function and checking If is last slide is true, then call the router dot replace and point to / auth sign up, just like this. Else, if it's not the last step, then use the swiper ref dot current dot scroll by 1. So this is how you scroll to the next screen. So you can swipe, but you can also click next, and now it will navigate to the next screen. And if you get to the last one, it'll actually move you over to the sign up. So now let's reload the screen to go back. Finally, let's see why this button is so slim. We need to make it have a bit more height. So let's navigate over to the custom button and let's give it a padding of 3. There we go, that's better. And to this touchable opacity, we also want to spread all of the other props. So we can do ... props. That means that whatever we pass right here as a class name or as anything else, we're immediately also transferring to this touchable opacity. In this case, it is a custom width and a margin top. And this is making it look so nice, and it makes it super customizable. With that in mind, our welcome screens are now complete. We can nicely scroll between them. You know how you can change the title and the description if you want to. You can navigate over with the buttons. You can press the skip at the top right, or you can just come to the end of the onboarding and press get started. An onboarding sequence is something that every single mobile application has. So now you know how to do it too. And moving forward, we'll focus on the sign up and sign in screens. So let's do that next by heading over to sign up. Our sign up page will have a bit more height than what some of the devices can fit on one screen. So instead of a safe area view, we'll render a scroll view coming from React Native. So let's import it, scroll view, and text coming from React Native. To that scroll view, we can give a class name equal to flex-1, as well as a background of white. Within it, we can render a regular view, which we also need to import from React Native. So let's do just that. And let's give it a class name equal to flex-1 and bg white once again. Within that view, we'll render one more view within which we'll render an image. So let's render that image right here. And that image once again will come from React Native. It'll have a source equal to images, which we can import from constants, dot sign up car with a class name equal to z of 0, w-full for full width, and h-250 pixels for the full height. And take a look at this nice image at the top. Let's also style this view by giving it a class name equal to relative, w-full, and h-250 pixels as well. Below the image, we can render a text, and that text will say create your account. And we can style it a bit by giving it a class name of text-2xl, text-black, font-Jakarta semi-bold, and absolute with a bottom 5 and left 5. So now we're absolutely positioning it just at the bottom of this image, but it's going a bit within it since we have a white gradient appearing right here. We can go below this view that's below the text, and we can create another view right here. This view will have a class name equal to padding of 5, and within it, we can render a custom component of input field. So similar to what we have done before with a custom button, we want to create a new custom component called input field.tsx. We can declare this new component input field, which is going to be just an immediate return function where we'll return something very soon, and then we can do export default input field. Now let's immediately import it right here. So import input field coming from components input field, and this input field will be within a special view, a view called keyboard avoiding view. Pretty interesting. Once you have this view, your keyboard will not be able to go into it, because if it did, how would you type into it? Okay, so that's why we have this keyboard avoiding view. And within it, we can also have a touchable without feedback. So this is similar to a button, but this time we don't really want to make it seem like we're clicking it. And we can import this from React Native. Within it, we can render a view with a class name equal to margin Y of 2 and W of full. And within it, we can render a piece of text that'll have a class name. It'll be template string of text-lg, font-Jakarta semi-bold, and margin bottom of 3. And we can also render the label style, which will pass through props, as well as a label itself. So now we already know that in the props, we have to get some things like the label, we have to get the label style, and later on, much more. So now let's pass those props while we're calling the input field from the signup component. We can pass things such as a label equal to name. We can pass a placeholder equal to enter name or enter your name. We can pass an icon equal to icons, which we can import from icons.person. A value will be equal to a form value. So right at the top of this file, we can declare a form for the signup by saying use state is equal to form, set form at the start equal to an object that has a name equal to an empty string. It has an email equal to an empty string as well. And it has a password equal to an empty string. And now we can use that value right within this first input field by saying form.name. And below it, we can call the onChange handler. So onChange text will be equal to where we get the value. And then we need to set up the form by saying set form. And first we have to spread the existing values of the form by saying .form and then update this specific field's value. So the value of this specific field is name, and we can set that over to be equal to value. I think I can expand this in a few lines, just so you can quickly see what's happening. So we're setting the form by first spreading all of the other fields and then updating specifically the name field with the name value. If I zoom out a bit, we can see it in one line, and that now allows us to go into the input field and accept all of these props. So alongside the label and the label style, we also have things like the icon, the secure text entry. So if this is true, that means that we're typing in a password, and by default, it will be set to false. We have the container style, the input style, the icon style, the class name, and finally, we can spread all of the other props that we have. So now we can continue with creating this field because right now we're just showing the label and nothing more. So let's go below this text and let's create a new view inside of which we can create the icon and the input. This view will have a class name equal to, it'll be a dynamic property of flex, flex-row, justify-start, items-center, relative, bg-neutral of 100, rounded-full, border neutral of 100, and on focus, border-primary of 500, and dynamic property of container style, if we decide to pass any additional properties. And now we're slowly starting to create this specific input. Within it, we can check if we have the icon. So if icon exists, then we can render an image, which we of course have to import from React Native. We can do that right at the top by getting the image from React Native. This image will have, of course, a source equal to icon and a class name of, it'll be dynamic, W6, H6, margin left of 4, and dynamic property of icon style. So now we can see this icon and what is soon going to become an input field. Below the icon, we can render a text input, which is a React Native component. So we have to import it from React Native. It'll also have a class name, which will be dynamic. It'll be rounded-full, padding of 4, font of Jakarta semi-bold, text of 15 pixels, flex 1, and it'll have dynamic property of input style, as well as text-left. It'll also have a property of secure text entry equal to secure text entry, and we can spread all of the other props that we decide to share with this input. So now you can slowly start seeing this input appear on the screen. Enter your name. We can style this input a bit further by modifying the keyboard avoiding view, and we can change the behavior of this view depending on the platform we're on. So we can use the special platform feature coming from React Native by saying platform, which we can import from React Native.os. And if the OS is equal to iOS, then we can do padding, else we can do height. I learned that this makes it work better on those specific devices. To touchable without feedback, we can provide an on press. And here we can run the keyboard coming from React Native.dismiss, which means that if we click outside or if we click within this touchable opacity or touchable without feedback, we will close the keyboard. Check this out. I click it, I click outside, it closes. Great. And now we have a single input field. We can also specify the types of those props, which are equal to input field props coming from types. And now that we have created this structure for input fields, it is super simple to just duplicate them below. 1, 2 more. The one below will have a label of email. It'll say enter email or enter your email. The icon will be icons.email. It'll say form.email. And under form, we will set the email right here. And for the third one, we can say password. So password, enter your password. Icons will be icons.lock. And here we'll pass the special secure text entry equal to true. Value is form.password. And finally, we can set the password here as well. And now we can see 3 fields and how simple it was to create them. Below those 3, we can do something even simpler, and that is call our custom button. We can provide it a title of sign up. We can give it an on press, which will call a special function called on sign up press. And we can give it a class name equal to margin top of 6. So before we save this, we just have to create this on sign up press functionality. So let me just add it right here above. Const on sign up press is equal to an async arrow function, which we'll create later on. But for now, you can see how simple it was to duplicate these 3 inputs and create a custom button right below. Right below this custom button, soon enough, we'll create our OAuth, meaning a special button that'll allow us to log in with Google. And below OAuth, we'll show just a regular link coming from React Native. That will point to /sign-in. And it'll have a text property of something like already have an account, ? And then we can render another text right below and say something like log in. But this one will have a class name equal to text-primary-500. Okay, let's style this link just a bit more by giving it a class name equal to text-lg, text-center, text-general of 200, and a margin top of 10. We can also create an empty space right here after the question mark, like this. And this is now looking so much better. Below this link and below the view, later on, we'll create a modal for the verification. So I can say verification modal right here. So now let's add this OAuth button, to which we can add the functionality very soon. I'll create a new custom component called OAuth. which typically stands for social authentication. Here, we can create a new component, const OAuth is equal to a functional component, and we can just export default OAuth. Within there, we can automatically return a view. Within that view, we'll have another smaller view that'll have a class name equal to flex, flex-row, justify-center, items-center, margin top of 4, and a gap x of 3. Within it, we can render one self-closing view that'll have a class name equal to flex of 1, h of 1 pixel, so height of only 1 pixel, and a bg general of 100. Below that one dot, we'll also have a text, which we need to import from React Native. And this text will have a class name equal to text-lg, and it'll say or, and then right below that, we can duplicate this view and show it here. So this is gonna look something like this. Even though we cannot see it yet, it'll be there soon once we call the OAuth component, which we just created. So OAuth, and we can import it automatically right here. I'm gonna skip the onboarding, and it should appear just above the already have an account thing, but we cannot see it yet. So to make it a bit more visible, we can go below this inner view and create a custom button. It'll look something like this, and it'll have quite a few props. A title equal to log in with Google. There we go. Now we can see it. We can also give it a class name equal to margin top, w-full, and shadow-none. We can also give it an icon left, which is going to be equal to a callback function that automatically returns an image. And this image will have a source equal to icons.google, a resize mode equal to contain, and a class name equal to w-5, h-5, and margin x of 2. And of course, we need to import these icons at the top by saying import icons coming from /constants / nothing, because the icons are exported from there. Now, if we head over to our sign up, you can see a button that says login with Google. Let's also give it an additional property of bg variant is equal to outline, because typically Google buttons don't have a color. Typically they're white. And the text variant will be set to primary, like this. There we go. That's a Google button. And finally, we can say on press, and that'll be equal to a function call to handle Google sign in. So this is a function which we can declare right here above. It'll have to be within the function, so it cannot be an instant return. Rather, we have to say return here, close it properly, indent it, and now we can declare the function const handle Google sign in, which will be equal to an async function to which we can add the logic very soon. So now we have the Google sign in button and the regular sign up, and we can click on the login to navigate over to a login screen. So if we click it right now, it'll be empty. And how will our login screen look like? Well, if we check out our design, you can see that it is basically almost the same as the sign up. It just doesn't have the name field because we already have our name. So for that reason, to create our sign in, I will duplicate the sign up, head over to sign in, and just override everything we have here while I rename it to sign in. So let's do that here, and skip, and head over to login. And there we go. We can see the same sign up screen here, but in this case, we'll make some changes. So let's go down. We'll keep the same sign up image, but instead create your account, we'll say something like welcome. And we can also do an emoji of wave right here. You can find it on Google and copy it. In this case, as I told you, we won't have the input field of name. Rather, we'll just have input fields for email and password. The button will say sign in, of course. And instead of on sign up press, here we'll have on sign in press functionality. So that's going to be on sign in. And we can use it here. At the same time, the form will only have the email and password. It won't have a name, so we can delete it from here. The link will also have a reverse logic right here. Instead of saying already have an account, we'll say something like don't have an account. And then we can say sign up. There we go. So now we have enabled switching between the sign in and the sign up after we modified the href right here. I click sign up, it goes there, sign in goes here, and now we can nicely move between the different screens. This is great. The next step will of course be to implement the functionality of registering our account. We'll first start by implementing the functionality of registering through the email and the password, and then later on we'll make the OAuth work as well. For authentication, we'll of course be using Clerk. It is more than just a sign-up box. It allows you to very quickly implement beautiful and super functional and secure authentication flows. And if you checked out a couple of my other videos, you know that it's completely free. For up to 10,000, not just users, but monthly active users. It is super hard to ever cross this number. But if you do, then you can start paying or make a switch. But if you never reach that number, it is completely free. And here's the best part. Clerk created a phenomenal Expo quick start, making it work so seamlessly with mobile Expo applications. The first step we have already done. We have installed all the necessary things and created an Expo app, but we just have to install the Expo Metro runtime as well. So let's just copy the second part of this first terminal command. We can open up a new terminal and paste it right here. npx expo install, and then a couple of these dependencies. We can continue following the other steps, such as installing the Clerk and the Clerk Expo package by pasting the command. After that, we'll have to set up our environment variables. And in this case, it looks like I'm already logged in. If you're not logged in, click the link in the description, which will allow you to follow along and see exactly what I'm seeing. And now I can see that this is not the right key for me either, because I have to create a new project. So let's head over to the dashboard. And as you can see, I already created many Clerk applications, but now we'll create a new one. I'll call it JSM_Uber. You can give it some other name. I think you can do something like Ride as well, but make sure to start with JSM. We'll choose email sign-in option as well as Google and click Create Application. You can see that they have the Expo setup right here, so we can continue following right from here. Here we have our environment test variable, so let's copy it and add it to our envs. I'll create a new file in the root of our directory called .env and just paste this environment variable here. WebStorm asks me if I want to install the .env file support plugin, which I will install. Now we can continue to the next step, and that is adding the Clerk provider to our root layout. So let's copy this entire file, head over to layout, and paste it right here at the top. You'll notice that we have some imports. We're getting that environment key, and we have a check if we don't have a key. After that, we need to wrap our entire application with the Clerk provider and the Clerk loaded wrappers. So let's copy them, delete this, and wrap our stack with the Clerk provider and Clerk loaded and close one by one. I indented everything nicely and it looks great. We can add this if no publishable key right within the root layout, below the fonts loaded. Now let's go to the next step, and that is to configure the token cache with Expo. For that, we need to install the new package, Expo Secure Store. So let's simply open up a new terminal and copy and paste the command. The next step is to copy this token cache. So let's copy it. And instead of cluttering the layout file with all of the authentication logic, we can put all authentication logic in another file. That can be with an Uber clone, and we can create a new folder called lib, as in library. And within the library, we can create a new file called auth.ts, inside of which we can post this token cache interface. And here we can also copy the token cache part of this next code block. We're not going to put it within the layout. We're just going to take the token cache. So let's paste it here. And let's make sure to get the secure store from Expo Secure Store and all the other imports that we need. So I'll paste it at the top of this file right here. We just need that. And I don't even believe we'll need the token cache interface. We can add it later on if it's needed. And since we'll use token cache somewhere else, for now, I'll just say export const token cache. Now let's go down. And the next thing is to create a home route group layout. I believe we call this root, and we already have it. The next step is to conditionally render the content depending whether we're signed in or not. We don't have to do this yet. We're going to do it on the homepage. Remember, we haven't yet signed in, so we cannot even see the homepage. But maybe it will be good to see this once we're actually logged in, to see at least something, to see a successful authentication state. So let's actually copy everything that is on here. That is indeed the index.tsx of the homepage. So we can override what we currently have in our app, root, tabs, and then home. And here we can paste what we just copied. If we do authenticate successfully, we should be redirected to this page, and we should be able to see our email address. Next, we need to protect our auth routes in the layout by creating a new route group auth, which we already have done, with the underscore layout file, and now we can do a redirect there. So let's copy this if statement and the use auth, and we can head over to index.tsx, which is our homepage. And here we can paste if signed in, use auth, and that's coming from Clerk Expo. We can also import it. So if we're signed in, then redirect to home, else redirect to auth welcome. In our case, the home will be under a bit of a different route. It's not going to be just /. It'll be /root /tabs /home. Okay. I hope that makes sense. That is the home page that we just added these clerk functionalities to. Great. So far, we're just following the steps. The next thing that it says is to add the sign up page. We already have the sign up page, thankfully, but we can copy this on sign up press function and on press verify function. So let's copy them, head over to sign up where we left off, and override the on sign up press with these new functions which we have just copied. With them, we most likely also have to get some of the states, or we'll have to make some of the modifications. I think we can add all of that on our own. The only thing we need is the call to the use sign up hook right here at the top, coming from Clerk Expo. So let's call this hook at the top, use sign up. And this is coming from Clerk Expo. So we can say import use sign up, coming from clerk, at clerk /clerk expo. We already have the form, that is good, but we also need the verification, because for clerk to work with React Native applications via email, we need to verify our user login or sign up via email. And this will be just a state. So we can use the use state snippet, verification, set verification at the start equal to an object containing the state equal to default, the error code, if there is one, at the start equal to an empty string, and the code the user is trying to enter to verify their credentials. That's also going to be an empty string at the start. Next, our email address and password are coming from a form. So we have to say email address and password are equal to form.email and form.password. Next, we can leave this as it is. And instead of set pending verification to true, we can say set verification, where we can say ... verification to spread all the existing information about the verification, but we can set the state to pending. If we get an error, we'll simply console log that error, and that's it for the signup. But we have to figure out what happens on the verification. The verification is the second part of the authentication. It's when we get the email with the code that's asking us to verify whether it's us who's trying to sign up with our email account. So we can say if not loaded, then return nothing, meaning exit out of the function. Else, we can try to complete the sign up. The code in this case will be equal to verification.code because that's where we put it within that specific state field. If complete sign up dot status is equal to complete, then we want to set active the session of the complete signup that created session ID. And we also want to modify the verification state to say ... verification, where we spread everything. But then we also want to set the state to be equal to success. Else, if it doesn't succeed, we want to set the verification to state is equal to failed. And then we can add the error message equal to verification failed. And finally, on the big catch, we can also set the verification error right here. But this time the error can be equal to error.errors0.long message. So this will tell us a bit more information about why the error happened. Finally, there's something that Apprite hasn't done here, and that is create a new user in our own database once a clerk user gets created. And that's what we want to do right here. So I'll say to do create a database user. So here later on, we'll make a database call to create a user in our database beyond just being a clerk user. But for the time being, we've been looking at this create your account screen for far too long, and I would just want to see something change. So let's try to authenticate with clerk first. But of course, to be able to do that, we have to create a modal that would allow us to type in the code that we got via email. So let's create a new modal right here below everything that we have. Verification modal. It is waiting for us. To create this modal, we'll install a new package, npm install react-native-modal. It's a very handy package that basically screams, don't reinvent the wheel. Somebody else needed a modal before, they created it, it is used by tens of thousands of people, if not more, and we're gonna make use of that modal in here as well. But of course, we'll style it to match our own application. So to start creating it, we can use it by importing it, by saying React native modal, which imports it from react-native-modal, and it accepts an isVisible prop. And it'll only be visible if the verification.state is triple equal to success. Next, within it, we can show a view, and that view will have a class name equal to bg-white, padding x of 7, padding y of 9, rounded-2xl, and min-h-300 pixels inside of square brackets. Within it, we can also render an image with a source equal to images.check and a class name equal to w-110 pixels for the width, h-110 pixels for the height, and margin x of auto and margin y of 5. If we save it, we cannot see anything yet because we haven't yet modified the verification status by entering our details. But thankfully, we can mock that verification status by changing the default state variable to success. And let's reload our application just to see the latest changes. I think sometimes it does get stuck. Oh, this time we have an error saying module expo local authentication could not be found within the project directory. This error seems pretty self-explanatory. It's saying that it's unable to resolve this package from Clerk Expo. So that might mean that we just need to install it manually. So let's copy the name, let's say npm install, and then say expo local authentication. Make sure to spell it properly. I often misspell authentication. And press enter. Once it gets installed, we can try to reload our application and see if that fixes it. Indeed, it got bundled. We are back on our onboarding, which is looking great. And it looks like we're still having this console warning from the root, but we're going to fix that very soon. For now, I will dismiss it. And we can see our beautiful modal. Let's continue creating it. Below the image, I'll show a text element with a class name equal to text-3xl, font-Jakarta bold, and text-center. Within it, we can say something like verified. Right below, we can do another text that'll have a class name equal to text-base, text-gray-400, font-Jakarta, text-center, and margin top of 2. And we can say something like, you have successfully verified your account. And finally, below the text, we can have another custom button with a title of Browse Home. On press, we can have a callback function that calls the router from Expo Router and replaces our URL to a string of /root, which is in parentheses, /tabs in parentheses, /home. And it's going to have a class name of margin top of 5. There we go. Verified browse home. Now we won't click it just yet, as it'll most likely break our application. But what we can do is actually test out the full functionalities of our authentication. We have added a lot of code. I'm not saying everything will work right off the bat, but we can give it a shot. I will bring back the default state of the verification to default, so it'll get hidden. And now that I think about it, instead of changing it to default, we're going to change it to pending, because that's the state that has to happen before success. So that means that we can go down where we have created our React Native modal, and now we'll have to create yet another React Native modal with a status of pending. So let's copy it, and I'll put it right here on top. React Native modal with a status of pending. Another property we can add to this React Native modal is onModalHide. And onModalHide, in this case, we can create a callback function, and we can set verification by spreading the verification properties and then changing the state to success. And now we can go inside of that modal and craft it by crafting a view. That view will have a class name equal to bg-white, padding x of 7, padding y of 9, we already know the drill, rounded-2xl, and min-h of 300 pixels. There we go. That's our modal. Within it, we can render a piece of text that'll have a class name of text-2xl, font-Jakarta extra bold, and margin bottom of 2. That's going to say something like verification. Below that text, we can have another piece of text with a class name equal to font-Jakarta and margin bottom of 5. And it can say, we've sent a verification code to form.email. So this is the email you entered during the form. Below this text, we can create an input field. Again, it is super convenient now to create it because we have already created this input field component that's going to have a label equal to code, icon equal to icons.log, placeholder equal to 12345, value equal to verification.code, keyboard type. This is something pretty interesting, numeric. In web applications, you cannot change your physical keyboard, but here you can. Next, we can also have the onChange text, which will request a callback function with the code you're typing in. And we can set verification to be equal to where we spread verification and then update the code. That's going to look something like this. Finally, if there is a verification error, we can show it. So if verification.error, Then we can render another piece of text that's going to render the verification.error. Of course, that text will be red in color, so we can give it a class name equal to text-red-500 and text-sm, as well as margin top of 1. And below that, we need to have a custom button, of course, that we'll use to submit it. So we can say verify email on press. Here, we're actually calling the on press verify, which is the function that we coded above, with a class name of margin top of 5 and BG success of 500. There we go. That's looking good. So what do you say that we give it a shot? I'll change the default state to default to Seer form. And now I'll start typing my name. It's Adrian. The email is contact@jsmastery.pro. And we can choose a password. Here we have very strict clerk rules, I believe. So if I enter 123123 and click sign up, we have an error. It seems like we cannot expand it right now. But of course, we want to show that error in some kind of a better place. And that's where React Native alerts come in. So we can scroll down to this catch where we just console log the error. And instead of a console log, we can actually alert it by using the alert functionality from React Native, .alert of a type error, and we can enter a message of error.errors0.long message. Now, if we save this and try to sign up with a basic password one more time, we got a nice error saying passwords must be 8 characters or more. Even though you cannot see it on the screen, I think my phone recording software is hiding it. I do indeed see 6 password dots on my screen. Now I will change it to 123 123 123 to pass over the 8-character minimum limit, and I'll click sign up. Now it says password has been found in an online data breach. For account safety, please use a different password. Very interesting. So it looks like we'll have to choose a real password. I'll enter something specific. I'll pause the video and enter a strong password and press sign up. This time, a verification modal appeared, which is a good sign. And would you look at that? JSM RIDE. Verification code just arrived in my email. So let's copy the code, or should I say type it in, 623263, and click verify email. And nothing? Where is our success screen? Why did we get re-navigated to the home? Are we signed in or are we not? Or should I say, was the account created or was it not? The best way to find out is to go to Clerk's dashboard under users. And here you can indeed see a new user that got created. But for some reason, the success modal didn't show. That's totally okay. Let's delete the user and let's give it another shot. In React Native, you can never show 2 modals at the same time. And if you scroll down, you can see that we're using the same state to go from pending and then to success. We have to use 2 different states to make that happen. So let's scroll up and let's create a new state. Use state snippet called show success modal. Set show success modal at the start set to false. Now we can scroll down and on our pending modal, instead of setting the verification state to success, we can do something else. We can say if verification dot state is triple equal to success. Then we can set show success modal to true. Let's just turn this into a function and properly close it. And now when we activate this second modal for success, we're not going to activate it by the verification.state. Rather, we'll activate it by this new show success modal state. So let's give it another shot. Let's create a new account. I'll again pause the video, enter my details. and press sign up. We get this new verification modal, which is great, sent to contact@jsmastery.pro. Indeed, we get back a new code, which I can enter on my phone. This feels so good. It feels like I'm trying to install or sign up for a completely new mobile application. 590082, verify email, and verified. There we go. I love how nicely it slided from the bottom to the center of the screen. And now we can click Browse Home. And it broke my application. Let's try to reopen it once again. By the way, we have to fix the borders here of the splash screen. So let's fix that right away. I think the fix is in the app.json, where we have the splash screen right here. We have to change the background color to match the blue color of the application. So that's 2F80ED. If we save it and reload our entire splash screen, you can see that now it appears perfectly on the screen and the blue covers the entire thing. Now we can skip the onboarding and try to sign up one more time. But I think the issue was with this router.replace thing right here. Instead of router replace, let's try to use a router.push. There are minor differences between the two, but this might just do it. So one more time, you'll have to reload your Clerk dashboard and delete this user in case you want to use the same email address. I'll pause the video and type in my credentials. I'll click sign up, enter my code, click verify, and browse home. There we go. It almost worked. We just have to hide the actual modal. The only thing we have to do to fix this is expand this router.push and add something to it. And that something is set show success modal and reset it back to false, because then once we re-navigate, it will no longer be showing. Great. So if I click it, as you can see, it works. Great. So now we can see our homepage and we can get rid of this ugly top bar. We can do that easily by finding the layout that is close to our home, which is this layout right here. And we need to copy one of the previous layouts that we've had. Maybe this one right here we had in the auth. We can copy it and head over to the layout next to the tabs, not the one inside it, but rather next to the tabs, and paste it here. Here we can just say name, tabs in parentheses, header shown is set to false. And for now, we can remove these other routes and just leave the tabs route group. I'll also open up the app once again. And actually, now might be a good idea to implement the authentication session to check whether our user has already authenticated, so we can automatically skip the onboarding and skip the welcome screen and skip the authentication screens and go straight to the home. I mean, think about it. That's the typical app experience. You're not going to sign in for the app or go through the onboarding every time you open the app on your phone. You're going to go directly to the homepage of that app. So let's do that next. I think it's going to be an easy fix. And it's not working right now because I accidentally skipped one of the steps in the Expo Clerk setup. And that is, if you go to this app layout, remember when I told you that we will take apart this auth TS token cache just to not clutter the layout? Well, I exported it, but I forgot to use it. So we have to pass this clerk token cache equal to token cache coming from libauth right here. Once you pass it, it should have access to the current user session. It is still not redirecting me back to home though, which is okay for now. We can retest it once again later once we implement the login functionality, because right now we just have the registration. So even if we did want to log in again with the same account, we cannot do that right now. So let's head over to the sign in component or the page and head over to this function called onSignInPress. If you head over to the Clerk Expo setup, if you scroll down, there's going to be the sign in page here as well, just below the sign up. There we go, sign in page, and it includes the onSignInPress. You can get to this documentation page by Googling for Expo Clerk Quick Start. Now I will override this function And we'll of course have to do some additional fixes, such as importing this use sign in functionality alongside the router. So we can paste that right here at the top. And we need to import the use sign in coming from at clerk/clerk expo. And we also need to import the use router. So let's do just that, use router from expo router. In here, they're using the use callback. So that means that we need to import the use callback from React. And as email address, that's just going to be form.email, and password will be equal to form.password. Other than that, I think we just need to fix it in one more place, form.email and form.password right here in the dependency array. And we have no more errors. Now we can try to sign in. Let's skip the onboarding. We've seen it quite a few times. Let's head over to login and enter the email and password you signed up with. I have stored it in my Apple passwords, and here's a cool thing. I can now just press password for Expo Dev, scan my face, and it automatically entered my email and password, and I can click sign in. And there we go. I got redirected straight to the tab's home. This is amazing. Now we can fix some of these routing issues that we have with the warnings at the bottom. For example, it is saying that no route name tabs exists in nested children. Tabs chat, tabs home, and tabs profile. So let's first check our layout next to the tabs. And here we have added a name of tabs, header shown false, but it looks like we're missing the navigation to point to the other screens on our main application, such as chat, home, profile, and rides. And we'll create the navbar, or should I say the bottom bar for your thumb, right within tabs and then the layout. And then we'll be able to navigate to all of these other screens. So let's do that next. To get started with creating our tabs, let's first declare the layout by saying const layout is equal to just a regular function. And it can be an instant return where we'll render the tabs coming from Expo router. And then we can export default the layout. So what are tabs? Well, tabs is like a navigation bar in web applications. It allows us to quickly switch over to other screens. This tab will have an initial route name, which will be equal to index in this case. And we can also provide a couple of different screen options to it. The screen options will be an object to which we can provide things like tab bar active tint color equal to white. And there's many other things that we can provide to it. For now, I will just leave this here. Within the tabs, we also can create different tabs.screens. Our first tab screen will be a self-closing component with a name equal to home and options, where we can render the title equal to home as well. Header shown will be set to false, and we can even modify the tab bar icon, which is going to be a callback function that returns a tab icon. And this tab icon will be a custom component which we can declare right here. Const tab icon is just an immediate return function that for now just returns a view. Within the view, we can have another smaller view coming from React Native, and within it, we can render an image with this icon. So we can import the image and render it right here. I just noticed that my iPhone simulator is no longer running, so let me hook it up. And now we can get into our application. And now if we fix this typo right here, we should be able to get into our application. I'll just reload it for good measure. And you can see that we're in. It says contact @JS Mastery Pro at the top. That's because we have set header shown to false. Otherwise, it would be here. So let's remove it. And let's continue working on the tabs. You can also start seeing the tabs appear on the bottom. And as we switch between them, we're actually going to different routes. Pretty cool. We have those routes as they're dynamically taken from these files we have created, because each file corresponds to a screen. Great. So why are we even adding these tab screens here? Well, to further modify how this bottom bar will look like, and primarily to change the icon. So here we can take the focused state of this icon, and if it's focused, we can pass it as focused is equal to focused, and we can pass a source equal to icons coming from index home. And now you'll be able to see that this one, the home, should have an icon. At least it will have it once we add it within this image. We can also duplicate this tab screen 3 more times. 1, 2, 3. The first time, it'll be for home. The second time, it'll be for rides, rather the history of rides. So we can say rides, and the title will be rides, and the icon will be list. The next one will be chat with a capital C, and it's gonna be icons.chat. And then the last one will be profile. Title will be profile, and the icons will be profile as well. If we save it, it's good, they're back, but now we can further style how each one of these looks like, or at least its tab icon. So let's give this first view a class name equal to flex, flex-row, justify-center, items-center, rounded-full, and if it's focused, then we can give it a BG general of 300, else we can give it nothing. But of course, for this to work, we have to make it a template string. So let's do just that. There we go, that's good. And this focus state is coming from props. So we can say source is for the image, and focused is for the focus state. And we can declare the types. Source is of a type image, source prop type, and focused will simply be a Boolean. The inner view can be styled in a similar manner. It can have a class name, which will be a dynamic template string of rounded-full, W of 12, H of 12, items-center, justify-center, and if it is focused, then we can give it a BG of general 400, and otherwise it's going to be just an empty string. Now you can see that we have this green selector icon. And for the image itself, let's give it a source equal to source, a tint color equal to white, a resize mode equal to contain, and finally a class name equal to W of 7 and H of 7 as well. And now we can see a nice looking home icon. But it still doesn't look that good. And that's because we haven't modified the actual tabs options. So we have many more options to choose how our tab will look like. Tab bar active tint color is just one of the options. We can also say tab bar inactive tint color, and we can also set that to white. Next, we have tab bar show label. We're gonna set that to false. That's because we have a nice looking icon. Next, we have a tab bar style, which will be equal to an object that's going to have a background color equal to hash 333333. And if we save this, you can now see this nice looking background. And finally, this is starting to look more like a real mobile app. We can give it a border radius of about, let's do 50. Let's give it a padding bottom of 0, an overflow of hidden, a margin horizontal equal to about 20, a margin bottom equal to 20 as well, height of 78, display equal to flex, justify content equal to space between, align items equal to center. Let's fix this space between. Let's give it a flex direction of row. And finally, a position of absolute. So this way, it will always appear on top of other content. And take a look at this. We have a beautiful bottom navigation bar with nice looking icons and activity status that allows us to switch between all of our 4 apps screens. And now we can go back to our homepage. So that's gonna be home. And we can put this within a safe area view. which is coming from React Native safe area context. Now we can actually see hello contact @JS Mastery Pro. And now if we reload our application by shaking it a bit and pressing reload, you can notice that we are automatically brought to our home screen, which means that we no longer have to go through that entire welcome, onboarding, and auth process. That's great. We have a clean slate to continue working on our homepage. So let's clean it up a bit. And sure, we could start adding more UI. But what's UI good for if we don't have it stored as real data that we're showing in our app? We want to make our apps truly functional and use databases to store users' data and then present it to them in a nice looking UI. For that reason, now is the perfect time to implement a database. And in this video, we won't be using any backend as a service tools. We'll be using a native Postgres database, and we'll even write real SQL queries. We'll do that with Neon, the database platform which I think is the best one so far, and even Vercel builds their Postgres databases on top of them. So if you haven't already created an account at the start of the video, click the link in the description to follow along and see exactly what I'm seeing and create an account right now. Once you do that, you'll be redirected to your Neon dashboard. Let me show it to you how simple it is to set it up. In this case, we'll be using the Neon driver. So let's copy this block of code and add it to our code. Just to keep our code clean, I'll put it in a new file, and this time it has to be added to a special file. In Expo, we have the possibility to create API routes. Does it sound familiar? It's because it's coming from Next.js. So we can create, in parentheses, an API folder, and then within it, we can create a new route for our user's API. So let's say new file, user plus API.ts. It's not dashes, it's not square brackets. Expo uses pluses in between. So user plus API. And here we can paste what we just copied. You'll quickly notice that we don't have this package installed, so just copy it, open up the second terminal, and run npm install, and install the Neon database serverless. Once you do that, we can store this database URL within our environment variables. So let's copy it, head over to our .env, and add it as a database underscore URL is equal to the key that you just copied. You don't have to keep the string signs, so make sure to remove them. Now we can go back in here and just use the process.env right here. So neon process.env dot database underscore URL. And we might need to wrap it in a template string because this needs to be a string. Great. And this exposes the SQL Neon querying function, allowing us to query anything we want from our database. We won't be querying it just here. Rather, we'll be using Expo's API routes functionality that we can call from, I wanted to say front end, but it's really from mobile screens. So let me show you how that works. The only thing you have to do is export a new async function, declare whether it's post or get or something else. You get a request as the first and only parameter, and you open it up. In here, you have a try and catch block, and you can do all the server logic right here. But let me explain this by referring to the documentation as well. What are API routes? They are functions that are executed when a route is matched. They can be used to handle sensitive data, such as API keys, or implement custom server logic. They're created by creating files in the app directory with the plus API.ts extension. For example, the following route handler is executed when /hello is matched. To create an API route, you just need to export a new function, either say get or post, and then return a response.json. That's it, similar to Next.js. And when it comes to how we can use the Neon serverless driver, well, it's pretty simple. You can use raw SQL queries or use tools like Drizzle or something else to fetch data. In this application, we'll be using native SQL queries, but if you want me to use some kind of an ORM like Prisma or Drizzle, just let me know. And this is it. Take a look. You just declare a new SQL instance by declaring Neon from Neon Database Serverless, and you provide your database URL. and you can immediately start querying it. Pretty cool, right? If you're not familiar with SQL syntax, I'll give you a phenomenal resource you can refer to very soon. But with that in mind, let's create our first post request that would create a user. We can move this SQL neon thing right within our post request because we have to declare it every time we make a new request. Then we can destructure some things that we're passing into the request, such as the name, email, and clerk ID. And that's going to be equal to await request.json. We're not passing those yet, but we'll pass it soon once we try to make a call to this API route. Next, we're going to check if we don't have access to the name or email or clerk ID. We're just going to return a response.json where the first parameter is an error, where we can say missing required fields. And the second parameter is the init, where we can send the status of 400. And it looks like I'm missing an equal sign right here. There we go. Now it nicely structures it for me. But if we do have all of these fields, then we can form a new response that we're getting from the database by saying const response is equal to await SQL. And now here we dive into the magic of SQL syntax, the most powerful way to talk to a Postgres or MySQL database. You just open up template strings, you expand it into multiple lines, and you can tell your database to do whatever you want it to do. The syntax, and a bit on the longer side, as opposed to using an ORM, but you have the full flexibility. So if you wanted to create a user, no longer is it just users.create or something like that. With SQL, you can say insert into users, and then you can choose what do you want to insert into it. In this case, it'll be name, email, and clerk_ID. And then you can define which values are you passing into these fields that you are inserting. So the values will be a template string of name, a template string of email, and a template string of clerk ID. That's going to look something like this. And even though this SQL query is quite simple, soon enough we'll dive into more complex SQL queries. So I want to share with you a course that I created, which will most likely be a paid course later on, but for now I will give it to you for free so you can practice your SQL knowledge before continuing with the rest of this project if you need it. The course is called Database Mastery, and it starts with pure SQL. It is currently available on our platform, and as I said, soon enough it will become paid, but for now I can give you free access. There we dive into database introductions, introduction to SQL, how to create tables and insert data, and main SQL parameters. You can access it by clicking the databases link down in the description. We'll revisit the course later on once we start writing more complex SQL queries. For now, we can proceed with the rest of this API call. We can return a new response, and we can say json.stringify, to which we can pass an object of data, which can be equal to the response. And as the second parameter to the response, we can pass a status of 201. And I just noticed that all of this should have been within a try. So I have to put this try block all the way above. There we go. And then we finally have a catch. So if we have an error, we want to console.log that error. And we can also return a response.json with the error and a status code of 500. Great. And this is our Expo API route, inside of which we're calling serverless Neon database. So how can we actually trigger this API route? Well, I've told you a bit about that when reading the documentation, but let me show it to you. One thing I'll do first is go to the lib and create a new file called fetch.ts. And inside of here, I prepared for you a helper function that'll make it easier for us to continually make fetch calls without writing so much code. So if you go to the README of this video, go to snippets, you'll be able to find a lib fetch.ts file. So copy it and paste it right here. you'll notice it has two functions. One is a hook, useFetch, which will allow us to simply fetch the data, and it already has built-in loading and error handling right here. So when we fetch the data, we can make sure that it's either there, it's either loading, or it errored out. And here's the part that actually helps us make the request. It is just a regular function that accepts the URL and the options, and it just calls the regular fetch with that URL and with those options. If the response is not okay, we throw an error, else we forward the response from that API call. So instead of writing this entire code every time, now we can just call the fetch API functionality. So let's call it within signup. We can navigate over to signup and remember where we have a to-do right here, create a database user. This is exactly what we want to do right now. So we can say await, and we can call this fetch API, to which we can pass, first of all, the URL /API/user. Why is it that? Well, because it is API user plus API. So it means it's an API route. And as the second parameter, we can provide all the options, such as a method of post, and then a body, which will be JSON stringify, to which we can pass an object of name is equal to form.name, email is equal to form.email, and clerk ID is equal to complete signup dot created user ID, like this. And now you know where these are coming from. Name, email, and clerk ID correspond to our API route, and they correspond to these request JSON data variables, name, email, and clerk. We make this call from when we sign up the user. We call our Expo API routes. We insert that data into the NeonDB database. At the same time, we create and connect the clerk user and set it to the session. So if we have done everything correctly, we should be able to go to the NeonDB database and go to the SQL editor. Inside of here, we can run some SQL commands. And within this GitHub repo snippets, I prepared for you one command that we need to run. It is under create users table SQL. So you can copy it, go back to the NeonDB console, paste it right here, and we can read it together. It says create table users. It's going to have an ID, which is going to be a serial primary key with a name, email, and clerk ID. And we can run this. It looks like we got an error. And if I run it again, it says statement executed successfully. It looks like there was an issue with the C character in the clerk ID. So just delete it and type it again and try to rerun it. I think it should work. Maybe GitHub MDX added some special characters here. Either way, the table has been created, and we can head over to branch tables, which is a new feature on NeonDB. This is pretty cool because we can immediately see the users table appear, which means that we are ready to test everything out, and alongside a new user appearing on Clerk, now a new user should appear on NeonDB as well. So going back to Clerk's dashboard, for one last time, I will delete this user because now, as soon as we create a new one, hopefully it will appear on both sides. So let's reload our application. Clerk session died, which is great because that means that we have deleted our user. And now before we go ahead and create a new account, there's just one more thing we have to do, and that is within the app.json. If we want to use Expo's server functionalities, we have to go under Web, Output, and change this into Server. That's going to enable us to do API routes. And alongside that, we also have to add a settings object into plugins right here for the Expo router. And we can do that by adding the origin. And here we can have any kind of a mock URL for our server. At least it can be a mock URL for development purposes. And in this case, we can do something like a string of https://uber.com. And since we have expanded this Expo router with additional options, we have to wrap it in an array. So now we'll have an array where the name of the plugin will be Expo router, and then we're showing the options as the second parameter. So that's gonna look something like this. I think we can even put it all in one line so it makes more sense. There we go. Perfect. And now that we have added this URL, we also have to add it to our environment variables. That's going to look something like this. Go to .env, call it expo underscore public underscore server underscore URL, and make it equal to this URL that we have right here. I think we need to end it with a /, so we can do that here and here. Now we can close these files, open up the terminal, stop it from running, and run npx expo start -c to rerun our application with cache cleared. And you'll notice that now it'll take a bit of a longer time to bundle, which is a good thing because it means that our app now has more things within it. So let's wait until it bundles. There we go. Soon enough, we'll remove this clerk warning from the bottom. And now we can try to register one more time. Make sure to delete your existing clerk account. I'll enter my name, and I'll also enter my email and password, and I'll click sign up. Here we get our verification code, 864307, and we can verify our email. There we go, verified. Browse home. We got redirected to home, but that's nothing new. We also get a new clerk user, but that's also nothing new. The most important thing is that if you go to your Neon console and go to table, check out the users table, and here our new user will be created. So soon enough, we'll be able to create additional tables for riders and drivers, and we can make a connection between all of that to store it in our database and display it within our app. Great work so far. Moving forward, we can finally start creating some of the UI for our homepage. So let's navigate to our home and let's dive right in. To get started with creating our homepage, we can wrap everything in a safe area view and give it a class name equal to BG General 500. That's gonna give it a nice looking grayish background. Now, for the first time in this course, we'll use something known as a flat list coming from React Native. A flat list in React Native is a performant interface for rendering basic flat lists supporting things like horizontal mode, header support, footer, separators, pull to refresh, scroll loadings. It's basically a UL, an unordered list, but with some additional functionalities for mobile devices, where you can pull to refresh, you can scroll horizontally, and they all nicely appear. It is also completely customizable, so you can choose exactly how each one of these elements looks like. But the gist is, you get some data, and then you decide how each one of these list items looks like, and finally, you render it within a flat list. I'll show all of that to you right now. So for the flat list to work, we of course have to have some data. So we can have a data object, and for now, I can make that an array of different rides. So how will each one of our rides look like? Well, it's gonna have an origin address, a destination address, different map information, a screenshot of the map, driver first name, last name, and more. So we could go ahead and create some kind of a mock list of rides right here. And that's exactly what I've done under these code snippets, just to make your life a bit easier. So if you scroll all the way to the bottom, you can see that we have mock rides. And this is simply an array with a couple of objects that allow us to mock 4 different rides, just so we can create their UI first and then implement the functionality later. So let's go ahead and copy this code snippet, and we can put it right here above our page. Const recent rides is equal to, and then we can paste this entire array right here. What we can do is just collapse it. That way we don't have to keep looking at this huge array, but we can now use it within the data. So let's just say data is equal to recent rides. I think I misspelled it. There we go, recent rides. And we can slice only the first 5 characters. So from 0 to 5, question mark dot slice, just to make sure that we actually do have them. Now that we have the data, we also have to have something else to figure out how we will render each ride. Or should I say how we should render each item within the list. And for that, we can use a prop called render item that allows us to specify how each one of these items will be rendered. So first, make sure to create a callback function that looks like this. You can destructure the item data like this. And then for each one, we can return a ride card, which is a self-closing component to which we can pass the entire ride, which is equal to the item. Of course, this ride card is another custom component that we have to create. So let's go to our components folder and create a new component called ride card.tsx. Here we can of course create a new const ride card, and we can export default that ride card. And you already know that it's going to accept only one prop, so we can destructure the prop of ride, which is going to be of a type ride is of a type ride, coming from the types. And here for now, we can just return a view. And within the view for now, we can render a text, and that text can render the ride.driver.first_name, just so we can see who is the driver. And don't forget to import the view as well as the text from React Native. There we go. Now we can go back to home and we can import the ride card coming from components ride card. And right at the top, I'm not sure if you can see it as it's very, very small. We have 4 different names of riders. We can make that a bit larger by giving it a class name equal to text-3xl. And there we go. We can see David, James, and Michael. That is great. So now our flat list has the data that it wants to render, and it also has a render item function that tells it how each piece of data should look like. So now we can go into the ride card and start developing it. First things first, we'll have to mention ride.driver, ride.geolocation, ride.destination many times, as we have too many properties on this ride. So what we could do is just destructure those properties at the top so we don't have to repeat ourselves. You do that by saying ride, and then you destructure it within a new object. We can destructure something like a destination longitude. We can destructure the destination latitude as well. Let's also destructure the origin address. We can destructure the destination address. I think we'll need a created at. So when was the ride created at? As well as the ride time. How much time does it take? We can then destructure the driver, and we can destructure the payment underscore status. I think this is going to be enough for now. So instead of saying ride.driver, now we can just say driver.firstname. Great. So let's start turning this ugly list of names into something that looks like this. Each one of the cards will have the pickup location, destination location, a photo of that entire path, and many more pieces of information. Quite exciting and a bit easier than what we have done so far in our application. This is mainly just the UI. So let's give this view some class names. I'll give it a class name of flex, flex-row, items-center, justify-center, BG of white to differentiate it from that gray background, rounded-lg to give it that organic look, shadow-sm, shadow-neutral-300, margin bottom of 3. So now this will create this card-like feel. You can see it on the right side or on your phone. And you can see how nice this list behaves on your phone. Next, we can move this text a bit below, and we can create a second view right here. This view will have a class name equal to flex, flex-row, items-center, justify-between, and a padding of 3. Within it, we'll have one more view, which we'll use to enclose the image. So we can give it a class name of flex, flex-row, items-center, and justify-between. Within it, we can render a React Native image. So import it and give it a source. This time, we'll refer to the source by the URI, which is going to be a template string of https://maps.geoapify. And this GeoApify is going to be such a cool API, which we'll use to transform the coordinates into an image where it shows a map and the start and 2 locations with the entire path outlined within it. So we'll have to head over to geoapify.com. As you can see, it is completely free for up to 3,000 credits per day, which is more than enough. And we can click Get Started. The only thing we have to do is basically create an account, which is free and no credit card is required. So simply continue with Google, create a project. I'll name it JSM_ride. Choose the API. I believe we're using the static map API, and it's going to give you an API key, which we can store into our ENVs. What you also get is a complete API URL example. So let's copy that and let's paste it right here instead of this URI. You can see it is very, very long right now, but we can cut it right here after lon and lat, as we'll be providing our own longitude and latitude, and we don't need any of these additional properties. So we can remove that. And we also need to grab our API key. So copy it, head over to our ENVs, and add a new one, expo public geoapify API key is equal to this number right here. Now, if we go back, we can structure this better by saying maps.geoapify.com v1 static map. Style is OSM bright, so we don't need this smooth. Width is 600, height is 400, center lon lat, and now we can add a colon, and then we can add a dynamic property of destination, longitude, comma, and then we can do another property of destination, latitude. We can add the and sign outside and say zoom is equal to 14. And finally, we have to provide the API key, which is equal to process.env dot expo_public geoapify API key. Make sure that everything is spelled properly right here, and that this expo public key is the same one that you have right here in your ENVs. We can also provide this image with a class name of a W of 80 pixels, H of 90 pixels, rounded -LG. Still not there, so maybe I can reload my application. Sometimes that helps once we update our ENVs. And there we go, the maps are appearing. You can see we have David, James, and Michael. And even though they're very, very small right now, it's gonna be so interesting to see once we put it in a better looking UI. Of course, I'm talking about something like this. So now let's continue with the rest of the UI. We can go below this image, and still within the same view, we can create another view with a class name equal to flex-call, margin X of 5, gap Y of 5, and flex of 1. Within it, we'll have another view to contain our icon that'll have a class name equal to flex-row, items-center, and a gap X of 2. And within it, we can render an image with a source equal to icons, which we need to import, .to, so which destination are we going to, with a class name of W of 5, which is about 20 pixels, and an H of 5. There we go. Now you can see this to icon. And below it, we can render a text that'll spell out the origin address. So now we can give it a class name equal to text-md and font-Jakarta medium. There we go. And now we can duplicate this view one more time below for the from destination. Or no, should I say to destination? This was the origin address. So in the second one, we can say icons.point, and I can change it to destination address. And to both of these texts, we need to add a special property of number of lines is equal to 1, because we don't want it to go over one line. There we go. Now we can see some different locations. At this point, it's safe to remove this driver first name as it's messing with our view. So if we do that, it's looking great. Now we can go below this text and below 1, 2, 3 more views. So only 2 are left at the bottom. There, we can create a view that will wrap the bottom part of our card. This view will have a class name equal to flex-call, W-full, margin top of 5, BG general of 500, rounded-lg, padding of 3, items-start, and justify-center. For the time being, this messed up our UI, but don't you worry about that. We can add another view right here with a class name equal to flex, flex-row, items-center, w-full, justify-between. Notice all times we're playing with flex properties, and margin bottom of 5. Within it, we can render a piece of text that'll just say date and time, and we can give it a class name of text-md, font-jakarta medium, and text-gray-500. Right below, we can duplicate this same text, and instead of saying date and time, we can render real date and time by saying format date, which we can import, and give it a created add property. Then we can do a comma, and once again call the format date function, and this time pass it the right time. And this format date is one of the utility functions that we can create. So let's quickly head over to our lib, and let's create a new file called utils.ts. This stands for utility functions. One of these functions can be export const format date that takes in a date string, which is a string, and returns a string. So that's going to look something like this. This is the perfect type of function that you would use ChatGPT for. It is pretty simple, not that complex, and it just gets the job done. So if you go to GitHub snippets, you'll see that I provided you with this libutils file, which you can copy and override this utils. You'll notice that here we have this format date that basically takes a date, turns it into a new date, gets the month names, and then returns it in a nice human readable format. We also have a couple of other functions right here, all created by ChatGPT. Now we need to import this format date function from utils. So let's do that at the top. Format date at /lib/utils. And we cannot see that yet right now because the layout is broken. I think everything is going in a row instead of a column. So let me scroll up and let's look into some of these views right here. Oh yeah, this second view should have been a flex-call, as in column, item start, justify center here, and a padding of 3. If you do this, check this out. Now everything falls nicely, and this date and time are also appearing right here with the correct information. Oh no, it's taking the date from the right time. This right here should have been a format time function. And we have to import it from libutils. There we go. 12th of August 2024, 8 hours. This ride took 8 hours. Interesting. Now let's go one text and one view down and create a new view, inside of which will show the driver information. So let's create its container by giving it a class name of flex, flex-row, items-center, w-full for full width, justify-between to stay consistent with the layout, and margin bottom of 5 to divide it from the next section. Within here, we can create a text. That text will say driver. So let's save it. There we go. Now you can see the driver. And if you pay close attention, and if I zoom it out just a bit, you'll notice that this view right here is exactly the same as this view. So what we can do is just duplicate this view talking about the date and time and put it right below. Next, we can change the date and time to driver, and we can change the information about the date and time to driver.first_name and driver.lastname. And take a look, that looks great. We can duplicate it a few more times. I'll do it once more for now. And this time we'll talk about the car seats. So how many seats does this driver's car have? So we can get to that by rendering the driver.car_seats. There we go. That looks great. Some have 5, some have 4. And finally, we can duplicate it once more to talk about the payment. So right here, we can say payment status, and we can render a payment status. You can see that it all says paid right now, but we can change the class names if it's paid to be green and if it's not paid to be red. So let's turn this class name into a dynamic template string, and we can say if payment status is triple equal to paid, then we can add an additional style of text-green 500, else we can add a text red 500. Let's make sure to close this properly. We start with a question mark, end it here, and close it right here. There we go. This is good. Now you can see that it all says green. We can also capitalize it. So here we can add capitalize. So the paid is capitalized with letter P. You can see how nice this form is. Like we can move it up and down, we can scroll it. It is absolutely amazing. And with that, we have just developed our ride card. It is looking great. So let's go back to home. And now that we have this ride card, I can show you the other properties of the flat list that allow us to further modify the look of that list, such as a class name, where we can provide it a padding X of 5, just to create some more space. There we go, that's nice. We can also add a keyboard should persist taps, and here we can say handled. So now if you tap on it, the taps should persist. This is preferred with flat lists. We can also add a content container style, which can be a padding bottom of 100. So now we'll have a bit more padding at the bottom, so we have space for our bottom navigation. Now here's another pretty cool thing. This flat list automatically allows you to define how an empty list component should look like. You just create a callback function and return a new view that defines what's going to happen if it is empty. So let me create a text first and say something like empty. Of course, we have to import the view and the text at the top coming from React Native. And now if instead of these recent rides, I render an empty array, you can see empty at the top. That means that it gives us the possibility to style it somehow differently. So let's do just that. We can give this view a class name equal to flex, flex-call, items-center, and justify-center. Next, we need to check whether we're currently loading or not. It is highly likely that sometimes we might be loading, so that's the reason why we don't have any elements. So for now, I'll just create a mock loading property and set it to false. Later on, this will come from real dynamic data. So within this view, we can check if we're not loading, then we can render an empty React fragment within which we'll have an image. That's another React Native component we have to import. And that image will have a source equal to images. Make sure to import that. No result. If we save this, it's gonna break because we have to have a second part of the ternary operator. So if we are loading, for now, we can just show a text that says loading. There we go. Now this is a huge no results image. So let's style it a bit by giving it a class name of W40, H40. Let's also give it an alt tag of no recent rides found. And let's give it a resize mode of contain. There we go. We can also give it a piece of text right below. It's going to have a class name of text-sm, and it'll say no recent rides found. There we go. As simple as that. Now, if we are loading, we can show something else. Not just a boring empty loader. We can render an activity indicator, and that is coming directly from React Native. It's going to be a self-closing component called activity indicator, and we can give it a size is equal to small and a color of #000. There we go. So now you can see a very small activity indicator while it is loading. Great. Let's collab this list empty component. And we can now bring back the real data because we don't want to be looking at an empty list. And this flat list is so versatile. As you can see, we just defined how it would look empty without using a ternary operator on the entire list. They just provided a handy prop. Another thing that the flat list component provides is the list header component, allowing you to define how a header should look like. Let's make it into a React fragment that's going to render a view. This view will have a class name of flex, flex-row, items-center, justify-between, and margin y of 5. Within it, we can render a piece of text that says welcome. And then we can render the user first name, and we can even choose to add a wave emoji. You can go to Google and quickly copy it. Welcome, and now we have to get the user's first name. Let's see where this user is coming from. Going to the top and collapsing the recent rides, we can see that the user is coming from the hook of useUser, which is coming from Clerk Expo. Let's console.log that user to see what data do we get in there. There we go. Take a look at this. There's a lot of data, but in this case, the first name and the full name are false. I believe that's because we haven't used the Google authentication. So far, we have just used the email auth. So maybe if we don't have the first name, we can render something else. Maybe user email addresses 0. I believe that should be the email address. No, it's email addresses 0 dot email address. There we go. So now it says welcome contact@jsmastery.pro. It'll look better once we authenticate using Google. Let's style this text just a bit by giving it a class name equal to text-2xl and font-Jakarta extra bold. Okay, so maybe 1XL will be good. Now below that text, we can also render a touchable opacity. What is that? That's a button. So what will this touchable opacity do? Well, it'll render an image that has a source equal to icons.out. And it'll have a class name of W4 and H4. So that is this little button at the top right that allows us to log out. So let's create a function right here. Const handle sign out, which is going to be equal to an arrow function. And now we can add it as an onPress functionality on this touchable opacity. So on press, we can handle sign out, and we can also give it some additional class names, such as justify-center, items-center, W of 10, H of 10, rounded-full, and BG of white. There we go. So now it looks great. And I don't quite like that we have the email address here. So what do you say that we split it? And we split it by the @ because most people have their name in the first place. And then we take the first part of that email right here by doing this. So now it's going to say welcome contact because I signed up with contact@JSMastery.pro. But for you, most likely this will be your name. Or let me know in the comments down below if it's something else. We can also add the capitalize right here so that now it says welcome. We can add a comma right here. Contact. Much better. Or it's going to be a first name once we do Google Auth. Great. And now I think we can make it a bit bigger with 2XL. Moving down below the touchable opacity and below one more view, we can render one of the most important parts of our application. And that's going to be a Google text input. That's going to be a custom input which we'll create. So let's turn it into a component by going over to the components folder and creating a new Google text input.tsx. You know the drill. It is const Google text input, which is equal to an immediate returning function where we export default Google text input. It's going to return a view, and within it, we can have a text that'll say search. Make sure to import the view and the text from React Native. So going back, we can now render this as a self-closing component. Of course, don't forget to import it from Google Text Input. And to it, we can pass some props, such as icon is equal to icons.search. We can pass it some container style equal to bg white, shadow md, and shadow neutral 300. And we can provide a handle press. So what happens once we press it? We want to handle destination press. And this is yet another function which we can define right here at the top, for which soon enough we'll add the logic. Now we can head into the Google Text Input to accept all of these great props. It's gonna be an icon. Maybe later on we'll pass an initial location as well. It's gonna be a container style, which we defined. Later on, we might wanna change the input background color. So we can say text input background color, and finally the handle press. And all of these will be of a type Google input props coming from types. So now we can style this view a bit by giving it a class name of a template string of flex, flex-row, items-center, justify-center, relative, z50, so it appears on top of other elements, rounded-xl, and finally, we can spread all of the other container styles. So now we can see the search appear right here at the top. And for now, we can give it just something like margin bottom of 5. There we go. So now we can see a nice looking search, or at least what is soon going to become a beautiful Google input from which you'll be able to select all of the different places in the world, starting from the places near you. So it's going to be very smart. Before we go ahead and create that Google Text Input, let's go a bit below and create another React fragment, inside of which we can render a text that tells us our current location. So we can say text your current location. We can give it a class name equal to text-xl, font-jakarta bold, and margin top of 5, as well as a margin bottom of 3. Below it, we can render a view that'll have a class name equal to flex, flex-row, items-center, bg of transparent, and h of 300 pixels. And within it, we'll render maybe the most important component of our application, and that is the map. So let's create a new file called map.tsx. You know the drill, create a new map, which is equal to an arrow function, where we can export default that map. And for now, we can just return a view. So let's say return a view coming from React Native and a text within it that'll say map. Beautiful. So now we can render this map right here within it, coming from components map, and you can see how it says map right here. So now we're getting much, much closer to this view right here, where it says, welcome, John. We have a sign out button, a beautiful Google autocomplete search, your current location, and then the recent rides at the bottom. So while we're here, let's go below this React fragment and create one final text, which is going to be similar to this your current location text. So let's copy it, and it'll say recent rides. There we go. So we have recent rides, your current location, and then finally a great looking search input. So now we only have one question, and that is, what do you want to do first? Since you cannot talk to me right now and I can only imagine what you're saying, I'll have to make a decision. And I really don't like this big hole in the center of our application right now. So let's do the map first, and then we can focus on the Google autocomplete later on. So I'll close the home and the Google Text Input, leaving us with the map. But of course, for that, we'll have to add a lot of functionalities integrating with Google's APIs. To integrate Google's services, you'll have to head over to Google Cloud Console. That is console.cloud.google.com. Next, you can create a new project. So just click New Project at the top right. I'll call it JSM-Ride. and I'll put it under no organizations, choose where I want to put it. It looks like I have to choose an organization, and then click create. I think it takes about a minute for your project to be created. There we go. It was actually 5 seconds. Let's select our project and head over to APIs and Services. Next, click Enable APIs and Services and search for APIs and Services. We can search for Places and select the Places API New. There we go. This is the one. They even refreshed the icon. And click Enable. It looks like the Places API New requires a project with a billing account. So let me try to cancel this and go back and search for just Places API and choose this one. It seems like we can enable the Places API, the original one, not the new one, without entering the credit card details. So just go ahead and click Enable here. It might ask you something else later on, but then just exit and it will be enabled. Let's go back and let's enable the second API we'll need, which is the Directions API. Go to it and click Enable. Great. It looks like it's enabling it right away. It did redirect me to this page where we need to verify our card to get started, which is totally okay because they're not going to charge us anything. But for now, I'll try to exit out of that and just go a page back. Hopefully we can do it without entering any details, but if we need to, we'll have to do that later on. Now let's head over to our dashboard and go to Enabled APIs and Services. Then click Credentials and then press Create Credentials and choose API Key. There we go. We just got our API key. So let's copy it, head over to our .env and type expo public Google API key and paste the key that you just copied. I think this should be enough and it should work if Google doesn't mess with us further. We'll see if it will work soon enough. Now we can go back to the map. To start implementing it, we'll have to install 2 new packages. So let's type npm install react-native-maps as well as react-native-maps-directions and press enter. As soon as they installed, we'll be able to use a map view. Sounds convenient, right? Map view coming from React Native Maps. Next, we can start passing it props that'll make it work. So let's give it a provider prop, which is equal to provider_default, which is coming from React Native Maps. That's going to be Google most likely. Next, we can give it a class name equal to w-full for full width, hfull so it takes the full height of the container, and rounded -2xl to make the borders a bit organic. And would you look at that? The map is here. Currently, for me, it shows the country of Croatia with its very interesting shape, as this is where I'm based at. For you, it's going to show something else, and you can see how fluid it is. I can zoom in, zoom out, and move it around, and it just works so seamlessly. Great. So with that in mind, let's continue modifying this map to make it suit the needs of our application. I'll give it a tint color equal to black, as well as a map type equal to muted standard. This will make it just a bit muted, so it fits the theme of our application better, and it allows us to better show the routes from and to different locations. In this case, we're not interested in seeing all the rivers and lakes and mountains. What we're interested in are the roads. Let's also turn off show points of interest by saying show points of interest is equal to false. Now, how can we change the initial region that it points to? Well, here we can say const region is equal to an object where we need to provide different things, such as the latitude, longitude, and more. Very soon, we'll calculate this dynamically. So we'll be able to pass it as initial region is equal to, and then we can pass the region right here. But for now, let's leave it as it is. We can also say shows user location and set that to true as well. And finally, we can make the user interface style light, as our application is in light mode. And I just noticed something. I mean, look at the bottom left corner of this map. It says Apple Maps. So it's not Google. The default in this case actually is Apple because I'm on an iPhone. If you're using some kind of a different operating system, you might get different map presented to you coming from map view from React Native Maps. How convenient. But we still needed to get that Google API key, which we'll test later on, for the places and directions. And you might have noticed how it found your location, but it didn't specifically pinpoint to where you are on the map. That's because if you don't grant your device location permissions, then it cannot know where you are, which might be good or not, depending on how much privacy you want. But all of the great applications to work properly need to have your correct location. Imagine if Uber didn't have your exact location. How would drivers know where to find you? So how do we implement the functionality of getting your exact location? Well, let me show you. We'll install a package called Zustand. So npm install Zustand. And no, Zustand doesn't have anything to do with knowing your location, but it has bare necessities for state management in React and React Native. So it is a state management library. You can think of it like React Context. It allows you to create a store of some information, and then you can use and update that information across your entire application. So let's do just that. Going back to our code, we can create a new folder in the root of our directory, and we can call it store. Within the store, we can create an index.ts file. There, we can import the create functionality from Zustand. Once we have the create function, it allows us to create a store. And we can do that by saying const use location store is equal to create. That function takes in one parameter, which is the state creator. So it is a callback function with an immediate return of an object. So it looks like this. You open up a callback function, and then you immediately write parentheses and then braces. This means that you're immediately returning an object. Here, as the first parameter of the callback function, we get a set function that allows us to set the state. Now, we want to export this use location store because once we create it, Zustand allows us to call it from any file. Also, we can define the type of that store. In this case, it'll be a location store coming from types. It'll have things like the user address, which at the start will be set to null. We can also give it a user longitude set to null by default. Next, we're going to have a user address, which is also going to be set to null. Destination longitude set to null. Destination latitude set to null. Destination address set to null by default as well. And then we have to have a setter function, set user location, which will take in a latitude, longitude, and the address. And we have to define the types of these. So that's going to be latitude is a number, longitude is a number, and address is a string. And this entire thing returns a function, or rather it's a function block. So let's type it out properly. Looks like I have a typo somewhere. Or maybe not. Maybe it's good, but the prettier is not formatting it yet because we're missing some things still. We'll fix it as we go. In this function block, where we're passing the latitude, longitude, and the address, we can now use this setter function given to us by Zustand to now actually set those values. So remember what I said, immediate return of an object, that is parentheses, and then curly braces, where we set the user latitude to be equal to latitude. We set the user longitude to be equal to longitude, and we set the user address to be equal to address. I think I have a typo here. That's why it's not fixing it. So if I fix the typo, there we go. This is better, but it's still complaining about something. It's saying that it's missing the user latitude. So let's make sure to fix that. User latitude. Yeah, indeed, it is missing. I have user address 2 times, and it's missing one more thing, and that is the set destination location. So that's going to be a second setter function, set destination location, which will be almost exactly the same as set user location. So let's just duplicate it. It'll also accept the latitude, longitude, and the address. And this time, instead of saying user latitude, longitude, and address, we'll say destination latitude, longitude, and address. There we go. Now it nicely saves it, and we have to rename it to set destination location. Now we can see our TypeScript and prettier and ESLint. Nobody's complaining anymore. And that's why I love TypeScript so much. Based on this location store, where we said how everything should look like, it is now saving your ass from making stupid mistakes and typos, as I have typed user address 2 times. Maybe you didn't. Good for you. But now that we have no red squiggly lines, hopefully this makes a bit more sense. We have some values and we have some setters for those values, where we set the user location and where we set the destination location. Great. So this is called a Zustand store. And now we have access to this useLocationStore hook, which we can call. Where are we going to call it for the first time? Well, it's going to be within our homepage. The first time we open up our application and log our user in. Right here, we can say const, and we can get the set user location, as well as set destination location. And that's going to be equal to useLocationStore, coming from store. Alongside getting these setters from the store, we also need one more thing, and that is a use state for the permissions, whether we have given permissions for our location. So we can say has permissions and set has permissions at the start set to false. And now we can create a new use effect hook that's going to take in a callback function and also a dependency array. Also, see how WebStorm adds this inlay hints about what each one of these parameters is. First is the actual effect, and then the dependency array. For now, we'll keep the dependency array empty. And within it, we'll create a new async function called requestLocation. Const requestLocation is equal to an async function, and we can call it immediately. So just right here, request location. Within it, we can get the status of a request for a location by destructuring the status by saying await location coming from React Native dot request foreground permission async. And this location is coming at the top from React Native. And you can see that right now it's having trouble getting this method from the location object. And that's because the location is coming from a new package called expo location. So let's install it. npm install expo-location. Once it installs, we can just import it at the top by saying import asterisk, meaning everything, as location from expo location. And it looks like I have a typo right here. It's permissions, plural. Now it's okay, and it knows exactly what this function is about. Asks the user to grant permissions for location while the app is in the foreground. Next, we can check if the status is not equal to granted, then we can set has permissions to false and exit out of the function. But if we did get the permissions, we can get access to a location by saying let location is equal to await location dot get current positions async. Next, we can extract the address from the location by saying const address is equal to await location dot reverse geocode async, to which we pass the latitude equal to location dot coords question mark dot latitude. And we can add the exclamation mark at the end because we know it'll be there just for TypeScript to know. And we can repeat the same thing for the longitude. Once we have that, here's the key part. We can call the set user location, which is coming from our store. And now we can update the latitude to be equal to location dot coords dot latitude. We can do the same thing for the longitude. And we can also store the address, which is going to be a template string of address 0 dot name, comma, address 0 dot region. And you can notice that here it's complaining about the await. All of this has to be within the request location function, which is async. So let's put it there and close the function right here. Now this will request location access and then set it to the store, which means that we'll be able to use it from anywhere else in our application. Okay, so if we have done everything correctly, a new pop-up asking your location permission should have appeared for you. You cannot see it here on my computer screen, but on my phone, I can see allow Expo Go to use your location. And I'll click allow while using the app. In case you gave access to Expo Go to your location before, then it'll already have it. But you can then switch it by going to settings and then say ask next time or when I share. So this time it's always going to ask you for the location. Great. So now that we're getting this location, we're actually not only getting it, but we're also setting it to the store, which means that we can now go back to the map and we have all the necessary information to figure out where our user is on the map. So let's extract that information by saying const and destructure the user longitude, user latitude, destination latitude, and destination longitude. And that's gonna be equal to use location store. And now that we have that, we can figure out our region. And what is a region? Well, region is a circle around you with a specified radius from within which we can search for drivers. And we can get the region by calling a special method called calculate region, to which we then need to provide all of this information, such as the user longitude, latitude, destination longitude and latitude, and that's it. But what is this calculate region? Well, it's one of the utility functions that you can get in the snippets down below. If you search for lib map.ts, copy this and create a new file in the lib called map.ts. Here we'll put all the utility functions for the map. It seems like a lot, but it's really not. We have three different functions here. We have the calculate driver's time, which we can nicely collapse right here. We also have calculate region, which is the one which we want to work on right now. And we also have generate markers from data. This is a function that takes in the drivers and mocks their locations around our circle. But later on, once we have real drivers, you can just get their coordinates and then use the same function to generate markers with slight modifications. Don't worry, I'll explain every one of these functions as we use them. So first, let's import the use calculate region within our map. It's gonna come from the map utils, and now you can see what do we have to pass to it. If there is no user longitude and latitude, it'll set some fake values right here. And if there's no destination longitude and latitude, it'll just take a delta, meaning a difference from our current user location. And just in my specific case, I'll take these mock values, I'll go to home, and when we're setting the user location, I will set them to these mock values, just so I don't have to allow for relocation every time. Now, if I go back to the map, you can see that we're getting the minimum latitude and maximum latitude based on the user latitude and the destination latitude. Once we have that, we add some padding, meaning we spread the circle around our user, and we further calculate it. As I said before, ChatGPT is perfect for these types of functions, but it's gonna make much more sense once we actually put it to action. So let me go back right here and let's put this region to use. I'll say initial region is equal to region, and I'll turn on the show user location. In my case, it is using this specific location I provided, which is right here in San Francisco. So the next thing we can focus on is showing some drivers nearby our location. And we can do that by going back to our store and creating a second store, which will be called use driver store. Here we can export const use driver store, you know the drill, and then we can say create with a type of driver store, and we get this setter functionality right here. Make sure to import the driver store from the types. And within here, we can set the drivers at the start equal to an empty array as marker data. Coming from types, it's going to be an array of marker data. And later on, we'll have a selected driver, which at the start can be set to null. We have to have a set selected driver, which is going to be equal to a callback function that takes in a drive ID of a type number and then calls the set functionality with its own callback function, where we can set the selected driver to be equal to driver ID. Right below that, we have the set drivers functionality to set all the drivers, which takes in drivers as an array of marker data, and again calls the set functionality, where it sets drivers to drivers. And finally, we can clear selected driver, which is just going to call a set functionality and set a selected driver to null. And it looks like I misspelled the driver ID. And in this case, there's so many different parentheses and braces and things to mess up. So what I'll do is I'll provide this index.ts of store in the code snippets in the GitHub README. So if you mess something up, you can copy and paste it from there. Now that we have that use driver store, we can make use of it in the map by getting the selected driver as well as the set drivers by saying is equal to use driver store. And now the question is, where are we going to get the drivers from? Of course, they're going to come from our NeonDB Postgres database. But for the time being, let's mock some drivers like we mocked our recent rides, just so we can see it on the screen. In the GitHub README, you can see a little toggle with mock drivers. So copy it and paste it at the top of the map file. Const drivers is equal to this array. Make sure to collapse it. Once you have the drivers, we can create a new use effect. It has a callback function, and it also has a dependency array that changes whenever the drivers change. In here, we want to check if the drivers exist and whether they're an array. So we can say if array.isArray, to which we can pass the drivers. And if we have the drivers, but if we don't have the user, so if no user latitude or no user longitude, in that case, we want to exit out of this. But if we do have the user location, and if we have the drivers, we want to create markers on the map. So we can say const new markers. And that's equal to generate markers from data. So this is a function that we created in the map utils, to which we can pass the data equal to drivers, and we can pass the user latitude and the user longitude, and that'll generate the markers. This is not too big of a deal right now because we have mock drivers. Later on, once we have the real ones from the database, it'll be okay. So now that we have these new markers, we can set them to the state. So let's create a new use state, and let's call it markers, and set markers at the start equal to an empty array, and they'll be of a type marker data, and specifically an array of marker datas. And after we create these new markers, we can simply set markers to be equal to new markers. And just to go to the map utils, I can explain how the generate markers from data works. Basically, it's getting the information about our user latitude and longitude. So where are we right now? And it's adding a random offset to mock the driver's locations so that it seems like they're next to us. Once you implement the real geolocation for the drivers, you won't have to do this. You'll be able to just show a couple of the drivers that are most nearby to the user. But now the question is, where do we show these markers? And how do we show them within the map? Let me show you. We can go to the map and specifically inside of the map. And here we can map over the markers by saying markers.map, where we get each individual marker. And for each marker, we can automatically return a new marker. This marker is coming from React Native Maps. So let's look into it. React Native Maps, we have a map view, And then before the provider default, inside of the curly braces, we can import the marker. But of course, the marker needs to have some information. So what we can do is give it a key equal to marker.id, give it coordinates, which are going to be equal to an object of latitude equal to marker.latitude, longitude equal to marker.longitude. We can give that specific marker a title equal to marker.title. And we can also give it an image equal to if selected driver is triple equal to marker.id, then we can render the icons coming from constants dot selected marker, else we can just render a marker icon, depending on which marker is selected. And would you look at that? We have 4 cars appearing next to our current location. For me, there is no pin about the where I'm at right now, but for you, there should be one. So it's looking even better. Now we have our current location showing on the map. We see the recent rides, and we see the drivers nearby us that can drive us somewhere. But the question is, where are we gonna go? And how can we tell that to our Uber application? To implement that, we'll have to focus on the second biggest part of our homepage. And that, my friend, is our Google text input. Finally, we'll be able to type something in and get the path drawn out from our current location to our destination location. So let's dive right into the Google text input and let's start implementing it. First things first, we have to install a package for the React Native Google Places autocomplete. And its name is exactly that. npm install react-native-google-places-autocomplete. We have a view right here, and directly within the view, where currently it says search, we'll render the self-closing Google Places autocomplete. And we have to import it right at the top from the React Native Google Places autocomplete. That's a mouthful. And immediately you can see a nice looking input appear, and if you click into it, you can start typing something. But it's still not showing any information. So let's continue styling it further and passing other props to it that it expects, such as fetch details, which can be set to true. We can also pass it a placeholder equal to search, or maybe something like where you want to go. Next, we can give it a debounce. This means that it's only going to make a request every 200 milliseconds. If it was going to make a request every key press, that would be too many requests. And we can also give it some styles. So let's create a large object of styles. We're writing CSS in JS here. And first, we can style different things, such as the text input container. So we can create that as another object. That's going to look like this. And we can say align items is equal to center. We can also say justify content is equal to center as well. We can give it a border radius equal to 20, a margin horizontal equal to 20 as well. You can see how it's moving it, and a position set to relative, and also a shadow color equal to hash d4 d4 d4. Next, we can style the text input. So let's go outside of this and say text input. We can give it a background color, which is going to be equal to either the text input background color or the color white. So this is the one we're passing through props, text input background color. Let's properly close this. It's also going to have a font size of 16, a font weight of 600, a margin top of 5, and a width of 100%. Finally, a border radius of 200 to make it not have such rough corners. Finally, once we can see some elements on the screen, we can style how they look like by modifying the list view styles. We can say that the background color of the list view will be equal to text input background color if it exists, or else it'll be set to white. We can also give it a position equal to relative. We can give it a top position equal to 0, a width equal to 100%, a border radius set to 10, a shadow color equal to D4, 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 and a Z index of 99 so it appears on top of other elements. Great. So now our input is looking great. But as we type, nothing is happening yet. So let's give it some additional properties as well, such as the on-press functionality. Once we press it, what do we want to happen? Well, first, once we press it, we can get some information from the press, such as the data and the details, which is at the start set to null. And then we can call the function and call a handle press function. And this function is coming through props. To it, we need to pass the latitude, longitude, and the address. So let's do just that. Latitude will be equal to details, ?geometry.location .latitude, or .lat, L-A-T. And we can add an exclamation mark because we know it's there. We can repeat the same thing with the longitude, but it's going to be LNG at the end. And finally, the address will be equal to data.description. Next to the onPress, we also have to define our query. So this is the search query, and the key here is going to be equal to the Google Places API. So this is something we can define right here at the top by saying const Google Places API key, let's make sure to spell it properly, is equal to process.env.expo_public_Google_API_key. And we can now use this Google Places API key as the key in the query. And we can set the language equal to any language in the world. I use EN for English. We can also choose to render a left button. So that's how customizable it is. Render left button, which will be equal to a callback function where we return a view that has a class name equal to justify-center, items-center, and a W of 6 and an H of 6. Within it, we can render an image coming from React Native with a source. And if an icon exists, then we return an icon. Else, we tap into the icons from constants.search. So you can see a big search icon on the right now. We can style it by giving it a class name equal to W of 6 and H of 6 with a resize mode equal to contain. There we go. That's much better. Finally, we can have one last property called text input props, which will accept a placeholder text color, which will set to be equal to gray, and a placeholder will be equal to either the initial location, so this is if we already have a location from before, or double question mark. This is to make sure that if we don't have the initial location, we can show something else. And that else is where do you want to go? Great. So now if I clear it, you can see where do you want to go. And if we start typing something like, let's see, Zagreb is the capital of Croatia, nothing shows up. Or whatever you start typing, most likely nothing is showing up either. And the main point of this Google autocomplete is for it to autocomplete exciting locations and cities near our location. So why is it not working? Well, when Google gave us our API key, I thought that they're gonna let it work. But it looks like if we go to Enable APIs and Services, and then search for Directions API, and then even though it is enabled, we have to go to Manage, and then we have to go through this verification process where the user card to verify that we're not a robot. They won't charge us absolutely anything until we manually decide to upgrade to a paid account. So this is just a strict verification to make sure that we're not a robot. So I'll click Agree and Continue. You'll have to enter some additional information and then proceed further. In a matter of seconds, my account was verified, and now you need to answer a couple more questions. You can say what you want to build, say what you're doing, choose the platform, and select a framework. Once you do that, it'll give you a new API key, which you can copy, tick on enable all Google Maps APIs for this project, and create a budget alert to help you stay on top of your spending so you don't get charged more. But that's almost impossible to reach. Given that, I believe you would need to have millions and millions of calls to reach that amount. So you can think of it as completely free. And then go to Google Maps platform. Now, I'm fully aware that some of you might not have a credit card, and that's totally okay. Some subscribers have told me in the comments of a previous video that for India specifically, there's also Ola Maps, which is completely free and you can get it without a credit card. So that's another thing that you can try out if Google is not an option. Or maybe other people in the comments will be able to tell you some alternative solutions if you really cannot use Google. But in this case, I'll be proceeding with Google. So it created a new project for me, and I do believe that the services are automatically enabled for Google Maps. So we can just use this new API key that has been provided to us, and I can paste it right here. Once you do that, and whenever you make some changes, you'll have to reload your application. So stop it from running and then run npx expo start-c to clear your cache. Now, if you open up the search once again and start typing something, you'll see powered by Google, and you'll be able to see some great locations appear on your screen. You'll be able to select from many of them. And the next step we'll have to do is to open up a new screen that'll allow us to verify your current location, your destination location, and then we'll be able to create a trip, which is a handshake between you and the driver. So to make that happen, we have to make sure that something happens once we press or choose a specific location. And that is coming through props from the homepage. So if we go to home, you can see that we're passing handle destination press, which is currently completely empty. Once we press it, it's going to give us access to a location that contains three different things: a latitude, which is a number, a longitude, which is also a number, and then an address, which is a string. What do we do with those? Well, we can call the set destination location, to which we can pass this newly selected location destination. Once we do that, we can use the router.push functionality to go to the second screen, / in parentheses route, and then find-ride. Now check this out. Even TypeScript didn't save me when I was setting up the name of the type within this location. It was okay with longitude, but in this case, WebStorm's spell checking found a mistake here. It was supposed to be longitude. So this was super useful. Next, we have to import the router from Expo Router. So let's do just that. And in this case, Expo is also pretty smart because it tells us right now that there's no such screen, find ride. So let's go ahead and create it. We can go to our file explorer, go to app, root, and then right here next to tabs, we can create a new file directly in the root. We can call it find-ride.tsx. There we can say const find ride is equal to a React arrow function where we can run export default find ride. You know the drill. We can there return a view coming from React Native, and we can return a text element for now saying find ride, just so we know if we have reached that screen properly. Now, if we go back to home from where we were redirecting, you can see that it's no longer complaining. And thanks to Zustand and our store, before we change the screen, we're also setting our destination location right here to the store so that even on the next screen, we know where we want to go. So let's give it a shot. I'll type Sacramento right here in California, USA, and it navigates me over to find ride. And just so I can prove to you that we actually know where we want to go, we can make use of the use location store. So let's head over to find ride, use the use location store by saying const something is equal to use location store. And here we can destructure the user address, which is our current address, and the destination address. And we can also get the set destination address and set user location in case we decide to change it. You know how in Uber you can change your current location in case you will be somewhere else once the driver picks you up. So now here in the text, I can give it a class name equal to text-2xl. And I can say you are here. And I can render the user address. I can duplicate it and say you are going to. And here we can say destination address. And now if I save this, you can see you are here, San Francisco, you're going to Sacramento. Wonderful. This is working like a charm. And we can even go back. And if we want to go somewhere else, let's say Palo Alto, we can also go right here. So let's do that next. As you can notice, the next three screens have a very similar layout. They have a map at the top, here, here, and here. They have some kind of a widget that appears at the bottom, which is this form right here, here, and here. And then you can slide it above to cover the map. So for that reason, I'll teach you how to create something very cool, and that is a layout component, so that we can reuse a very similar layout, but then change what's shown within it. So let's go to components and create a new file called ride layout.tsx. It'll be a component like any other, starting with const ride layout, which is a React functional component. We can export default.ride layout, and then we can return some kind of a view right within it. The difference between a regular component and a layout component is that layouts typically accept children as props. So we can define children right here, and it'll be of a type children is a React node. What does having children allow us to do? Well, first of all, we can have some kind of a text that allows us to say top of the layout, and we can duplicate that to say bottom of the layout. But then in the middle, we can render whatever we show in the children. So if I do this, we can now go back to find ride, and I'll wrap my entire application with the ride layout. Of course, make sure to import it from components. And check what happens. Now we have top of the layout, bottom of the layout, and then in the middle, we have whatever we have right here. For now, we can leave that just to be a text that says something like find ride, because this is the screen that we're currently on. Now later on, we'll be able to reuse this layout on other screens as well. Screens such as these ones right here in the root layout. First, we have the find ride, so we can also hide the header on it. Later on, we'll also have a confirm ride, and finally, we'll have a book ride. And we want to hide headers from all of them. As you can see, our layout is now complaining about too many screens defined. So for now, I will comment out the bottom two. And let's continue working on our ride layout. Instead of having a top and bottom text, we'll do something different. I'll wrap everything in a gesture handle root view like this. And that's going to come from a new package. So let's install it by running npm install react-native-gesture-handler. Once it installs, we'll be able to just import it from there. This will allow us to swipe our screen and then show something underneath it. Before rendering children, let's render some other stuff here, like another view with a class name equal to flex-1 and bg-white. Within it, we can render yet another view with a class name equal to flex-call, h-screen for full height, and bg-blue-500. I'll go back to my screen, And now we can see that the entire screen is blue. We can show another view right below it, or right within it, with a class name equal to flex, flex-row, absolute, z of 10, top of 16, items-center, justify-start, and padding x of 5. Nothing will show yet because we have to put something within it. And that something will be a touchable opacity, which is basically a button. On press of this touchable opacity, we'll call a callback function that'll call the router dot back. So we can just go to a page back. And within it, we can render a view that'll render an image with a source equal to icons coming from constants dot back arrow with a resize mode of contain and a class name equal to w6h6. Now you can see a little back arrow right here on top left. We can also style it further by giving this view a class name of w10, h10, bg white, rounded dash full, and we can also give it items dash center and justify dash center to put it in the middle. Great. So now we're starting to create this backdrop. Right below the touchable opacity, we can also render a piece of text that'll say either a title, so it'll render a title that we pass through props. So alongside children, we can also get the title, and the title will be of a type string. If we don't have a title, then we can render a piece of text that'll say something like go back. Let's style this a bit by giving it a class name equal to text-xl, font-Jakarta, semi-bold, and margin left of 5. Right below that view, we'll render a map coming from components map. Thankfully, we have already crafted this component. And that's going to go below the view, not below the text. There we go. So now this makes much more sense. For the first time ever, we can see a map right here on our entire screen. How nice is that? But here's the key part. Going below this map and below the view, we'll create something known as a bottom sheet. And this bottom sheet is coming from another custom package. It has more than 300,000 weekly downloads, and it provides this nice bottom sheet that you can swipe up. And you can see the perfect use case is maps. So let's copy this installation code, open up the terminal, and run npm i at gorham/bottom-sheet. And now we can very easily import it from there. This bottom sheet also requires a ref. So we can say const bottom sheet ref is equal to use ref coming from React of a type bottom sheet at the start set to null. Now we can provide this ref to this bottom sheet by saying ref is equal to bottom sheet ref. We can also give it snap points. So these are the two different points at which the sheet will stop. So we can put that as an array, and it can be equal to, let's do something like 40%, and then the second one can be about maybe 85%, like this. And then we can also give an index of 0 to this bottom sheet. Within the bottom sheet, we can render the bottom sheet scroll view that'll have a style equal to flex of 1 and a padding of 20. And within it, we can render the children. So this is where the magic happens. If I now go back right here to search, you can see that now there's a find ride text. And if I scroll up and down, it gets stuck at 40 and 85% respectively. But again, the key part is that whatever is right in here, what we're wrapping with the right layout, shows directly within this little view that you can then move up and down, but the map remains right on top of it. This is such a beautiful user interface. So now the layout is mostly done, And if we go back to our find ride, we can start implementing whatever is supposed to be within it. Let's first give it a title equal to ride, and let's create a view right within it. This view will have a class name equal to margin y of 3, and within it, we can render a text element that'll say from. So where are you coming from? It'll have a class name equal to text-lg, font-jakarta semi-bold, and a margin bottom of 3. Right below it, we can render a reusable component which we have already created called a Google text input. Of course, we have to pass a couple of props to it, so let's do just that. We can pass it the icon equal to icons, coming from constants, dot target. In this case, we already have an initial location as well, equal to user address. So now you can see we already know where we're coming from because it's taking it from a user address location. Next, we can provide some container style equal to bg neutral 100. And we can also provide a text input background color of hash F5, F5, F5. And then what happens on the handle press? Well, we can call a callback function where we get the location and we simply set user location to a new location that a user has chosen. In this case, it's complaining a bit about the initial location. Maybe there's a type mismatch. I'll just add an exclamation mark at the end because we know it'll be in the right format. We can end this view right here and check this out. I will simply duplicate this view below and say not from, but rather to, change the icons to map, change the address to destination address. You can disregard my low battery sign. I'll go ahead and go charge it soon. And we can also change the text input background color to transparent. Here, instead of set user location, we'll set the destination location. I'll close my battery warning, and would you look at this? We have two different inputs, from and to, and we can change both of them by typing once again. So in San Francisco, I can type and go from, let's say, somewhere else. There we go. But I do get a warning here saying that virtualized lists should never be nested. And if we close this, I'm guessing a similar thing will happen right here. Yep, you can see virtualized lists should never be nested. We'll fix that very soon. But before we do that, let's quickly add a new custom button right here below. It's gonna say find now. Remember, we're trying to find drivers. And what are we gonna do on press? Well, on press, we will use the router coming from expo router to push over to / root in parentheses / confirm - ride. And we can give this button a class name equal to margin top of 5. There we go. This is looking much better. Of course, we have to actually create this route. So let's add a new stack screen that's going to say confirm ride. And let's create a new file in the app root, and it'll be called confirm ride.tsx, where we can create a new const confirm ride. And then we can export to default that confirm ride. That'll for now return a view and a text saying confirm ride. One thing that could be the issue here is if we go to the ride layout, remember it's mentioning something about scroll views. So what if we just use a bottom sheet view right here and not a bottom scroll sheet view? We can import it, remove the other one, and give that a shot. We don't need a scroll within a scroll. I think that's what it's complaining about. So if one more time we go into here and we need to bring it a bit up and enter something like Switzerland, now it works. Perfect. There's one thing we could try though. And that is coming directly from the keyboard behavior of the bottom sheet component. They say that we can define the keyboard appearance behavior, and we can use the extend or interactive to offset the sheet by the size of the keyboard. So by default, it is interactive, so we can switch it to maybe extend. We can do that by giving this bottom sheet a keyboard behavior equal to extend. But even if I try that, it doesn't seem to do the trick. Maybe on Android it works, so we can leave it as it is because by default it is indeed interactive. But we'll have to figure out something else for iOS. Maybe we'll have to pass custom snap points to this ride layout by saying snap points is equal to, and it can be an array of something like 85%. So now if I go to the ride layout and accept those snap points, which will be an array of strings. So we can say snap points is optional and it is an array of strings. We can now either render 4085 by default, or if we have the snap points, we can then render it by snap points. So what this is going to do is every time that you're here, it's always going to be opened at least 85%. This way, you can see the from and to locations very nicely on the screen here. And on this screen, you're not supposed to be looking at the map anyway. You're supposed to be checking whether the from and to are correct. So with that in mind, we got that fix. So let's click Find Now, which is going to redirect us to Confirm Ride. This is the second page where we'll reuse the ride layout. So I'll show you how convenient that is. Check this out. Instead of a view, I'll use the ride layout coming from components. I'll give it a title, which is going to be choose a driver. And I'll give it snap points, which are going to be custom of about 65% for the first one. And we can do 85% for the second one. Within it, we can render a flat list. The data for the flat list will be the drivers that we can choose from. And I do believe that we already have some fake drivers. I think it was maybe in home. Let's see. Here we have recent rides. Maybe it was in the map. Yes, right here at the top of the map, we have the mock drivers. For now, let's simply copy them and add them at the top of the confirm ride. I promise soon enough we'll make this dynamic. But for now, for the flat list, data will be equal to drivers. Next, we can choose how we want to render that item. So we can say render item. We have a callback function where we get access to that item. And for each one, we return a driver card. So this is another component which we can create in the components folder. Let's create it by saying a driver card.tsx. You know the drill. Const driver card is equal to a simple immediate return component where we render a view with a text that says something like driver. And we can immediately export default that card. Going back, we can import this card. And if we render it, we'll have to go back. Let's go to Scranton, Pennsylvania, and click Find Now. And we can see 4 different drivers. To each one of these drivers, we can pass the item, which is basically the entire information about a specific driver. Of course, in the driver card, we'll have to accept that prop. So let's do that right away. It'll accept the item of a type rider card props. And basically what we're developing here is this card, where we show a profile photo of the driver, their name, their rating, how much they cost, how much it would take for them to get to us, and how many seats their car has, as well as their car photo. To speed up our workflow just a tiny bit, you can find it right here in the snippets. Copy it and paste it here. You'll notice that it is nothing more than a touchable opacity, basically a button that you can click that has an image and then with some repeated pieces of text. That is it. We can nicely scroll through it. We can click on them. This is looking great. The only thing we're missing back at confirm ride is going to be this time not a header, but a list footer component where we can define a callback function and then define a view, which we can close, that'll have a class name equal to margin X of 5 and margin top of 10. And within it, we can render a custom button with a title select ride. And on press, we can run the callback function that calls the router dot push to / in parentheses root / book dash ride. So right now it is red because we don't yet have that route, but soon enough it'll be there. Before we go ahead and create it, there's one more thing we have to do, and that is create a completely new store. So right now we have the store for the location, but right below it, there's a store for the drivers, where we're keeping track of all of the active drivers and we're keeping track of which driver has our user selected. So we can access that store like we're used to so far by saying const something is equal to use driver store, and from it we can extract the drivers, we can extract the selected driver, as well as set the selected driver to the one that we click. So to the driver card, we can pass the selected equal to selected driver, and we can add the exclamation mark at the end because we know it exists. And then we can call the set selected, where we have a callback function where we can call the set selected driver, and to it we can pass the item.id, basically the ID of the driver we're selecting. And in this case, the drivers here override the drivers above, which is okay because we don't need to define them 2 times. Rather, I'll remove the drivers from here, and back on the map where we use the drivers for the first time, we can call the set drivers, go into the use effect, and right here at the top of it, we can say set drivers and pass our current fake drivers that we have at the top. There's going to be a type mismatch, but don't worry too much about that. This will have to be removed anyway very soon as we add real drivers. So now let's create the last screen in our flow, which is going to be book ride. We can do that by going to root and creating a new file called book_ride.tsx. It's going to be a const book ride component, and we can run export default book ride while we return a view with a text that's going to say book ride. In the layout, we can also add book ride back just so we can remove the header. Now, let's go through our entire process one more time to test it out. Of course, the last screen being the book ride. Oh, and don't forget to add a return statement right here before so that everything works. So if I do this, and if I go visit Michael from the office to Scranton, Pennsylvania, I'll click find now. We can see different drivers. Soon enough, we'll be able to select only one. Right now, we're selecting all of them, and we can click select ride. And that's going to lead us to the last screen in this ride selection sequence, where we can finally confirm that this is our driver and we are ready to book a ride with them. And in terms of actual design, this is the page we'll develop next. As you can see, it is very similar to previous pages. We're still using the ride layout, and then we show something in the bottom sheet. We're so close to getting to the payments part, and we've already done a lot of UI. I really want to focus on the functionality. We've been using fake drivers and fake rides right here on the homepage, so it's about time to turn all of that into real data and real database interactions. So, just so we can do that very quickly, I just provided you with the UI for the root book ride, which you can copy here and just paste in this book ride page. Just make sure to fix this import where it's going to say ride layout. And there we go. Now we have the ride information, but it seems that it's not properly picking up the driver information. I think I know why. In the map, we're using fake drivers, and their IDs are strings. So when we're confirming the selected driver, we have to turn it into a number. So we can wrap it just like this into a number. And back in the book ride, we can now console log both the drivers as well as the selected driver. So we can do it just like so and save it. We can see that selected driver is a string of 1, and we can see all drivers, and there should be one with the ID of 1. So now it's just comparing the driver.id, which is turned into a number format, which is equal to the selected driver ID. So if I go back, choose one of these, there we go. We can see the right information, and just the pickup time is not good. So right here for the pickup time, we can check if there is driver details time, or we can say something like 5 minutes. This is going to be fixed once we have the real data. But right now, this is looking great. The only thing that is missing on this screen is the confirm ride button. But that won't be just a simple button. It'll open up the entire Stripe payment window, where we'll be able to choose from many different payment options and issue a payment, after which we'll be redirected to the success modal screen. So for the next step, we can scroll all the way down below this view, and we can render a new component, which we can create under the components folder, and we can call it payment.tsx. It'll be a React functional component called payment. We don't have any props for now, but you know the drill. It will return a view that'll have a text that'll say payment, and we can do export default payment right here at the bottom. Now, back in the book ride, we can now import the payment, and you can see it right here at the bottom. The payment itself will simply be a React fragment that'll load a custom button. So here we can say custom button with a title equal to confirm ride, a class name equal to margin y of 10 to divide it a bit from the top and bottom, and on press, we want to call a function called open payment sheet. This is coming from Stripe. So we can declare this function right here. Const open payment sheet is equal to an async arrow function, which for now we can leave blank. So if we quickly go back to that last screen that we had, you can see that now there's a confirm ride button, which means that we can focus on implementing the payments. Big step ahead, so let's dive right into it. Great job on coming this far. For payments, we'll of course use Stripe, one of the largest infrastructures for accepting any kind of payments online. So head to stripe.com and start now. You can create a new account or sign in. Once you sign in, you can turn on the test mode, and that'll make sure that all the information that you can see here is test data, so no real transactions will be processed here. Then you can go to developers and API keys. And here you should have some of the standard keys, or if you don't have them already, you can just create them. So I'll copy my publishable key, and I'll head to my .env and add a new expo_public_stripe_publishable_key and make it equal to the key that I just copied. We'll also need our secret key. So let's copy it and add a new stripe_secret_key. We don't have to add expo public before because we'll use this only within the API routes, so it is truly secure. Now that we have our keys, let's open up the documentation page. Thankfully, Stripe's docs are one of the best documentations out there in the development industry, period. So I'll link this documentation page down in the description where you can collect payment details before creating a payment intent. And thankfully, they have guides for web, iOS, Android, and React Native. So we can just follow the steps. First, we have to install and set up Stripe. We can install Stripe as well as Stripe React Native. So let's copy this and paste it in our terminal. And alongside that, I'll also copy this other part using npm. The first one is server-side Stripe, and the second one is Stripe for React Native SDK. Once we do that, we want to initialize Stripe by using the init method. And this is within the Stripe provider. And do you know where we'll use this? Well, we'll only wrap our book ride page with this. So let's go ahead and copy this entire file, close all of the currently open files, and just open up the book ride. I can zoom this out just so we can see what's happening a bit better. And I'll paste it right here at the top. We'll have to make some modifications. For example, we won't be needing this entire new functional component. Next, we'll have some use effects, functions, as well as use states that we can copy and move into our book ride function. And finally, we have the Stripe provider itself, which we can copy and wrap our entire ride layout with. And finally, we can close this Stripe layout. Or rather, should I say Stripe provider. So I'm gonna do it just like this. And save. As you can see, now we have copied over the logic for Stripe. With that, we have to import use state from React, as well as import use effect from React as well. Next, we need this fetch key functionality. And this is going to be a call to our own server from which we can fetch our secure Stripe key to make sure that we really want to process that payment. For now, I will comment this part out. Next, we can scroll down and we need to enable different payment methods. That's in the payment method settings. So if you follow that link, you'll see many different options that'll be enabled depending on where you're at. But for now, I'm okay with Apple and Google Pay as well as cards. So I'll leave it as it is. And we can collapse the first two steps entirely. The third step is to set up a return URL on the client side. And they say that we can put this within the app.tsx. We can skip this part because if you're using Expo, it says to set up your scheme in app.json, and that has already been set up for us. So thankfully, we can skip setting up the return URL. Next, we can collect the payment details on the client side. So we need to initialize a payment sheet. We can copy this entire part of the code, and this will go on the checkout screen. In our case, that'll be the payment screen. So we can go over to payment, and we can paste it right here at the top. You'll notice that we'll have to remove the closing function block and remove the export default checkout screen because we already have our own payment screen. Let's save it. Let's move the import a bit up. And now this is starting to make a bit more sense. I will collapse everything just so you can see what's happening. And we also need to move just a few things from the book ride. It's gonna be the publishable key, fetch publishable key, and the use effect. We can move those things over to the payment as well, just to have everything in one place. I'll paste it right here. We can move the states to the top right here. And the only thing we have to change is now that we have moved the publishable key, we have to actually fetch it from environment variables in the book ride. So we can say process.env.expo_public Stripe publishable key. And I'm gonna add an exclamation mark because we know that it'll be there. And we can move the imports for the use state and use effect over to the payment. Oh, we already have it. Great. So now let me zoom this out a bit so you can better see it. And let's see what we have so far in the payment. We have this publishable key, which we won't really need because it's gonna be coming from environment variables. So we can delete that. We have the init payment sheet and present payment sheet. So we first have to initialize it and then we can present it. We have a function called initialize payment sheet, which we'll call when we want to initialize it. And we have a confirm handler, which they put here for us, and it'll be explained later. And in our case, we don't need this function to fetch the publishable key. We'll just use our own API calls to fetch it. So I can remove the use effect as well, just to make it a bit simpler. There we go. Now it's pretty simple. We have a function to initialize it, a function to open it, and our own onPress function that should actually call these functions and make the magic happen. And that's exactly what happens in the next step, where we decide to present the payment sheet. So we don't need to copy this entire function block. We can just copy what's in it. So the const error and then ifs and elses. And we can paste it within the open payment sheet. Here, we also need to import the payment sheet error. And before we present the payment sheet, as I told you, we first need to initialize that payment sheet. So right here at the top, I can say await initialize payment sheet, which we call as a function. Once we initialize it, we can check if there are any errors. And if so, we can just let people know that there are errors by using the React Native's alert functionality. So alert.alert, make sure to import it. We can say error code is error.code, and we can also render the error message. There we go. Else, if there's no error, we can set a new state of success. So let's define that new state right here at the top by saying use state. I'll call it success and set success. At the start, set to false. And then in the else right here, we can set success equal to true. And we don't actually need this secondary if and else. We just need the inner one. So if there is an error, we show this, and then else we can set the success. Great. So this is a function for opening a payment sheet. Let's see what else do we have to do. Finally, we have to confirm the payment, but we haven't even tested whether everything works so far for us. So before we can confirm the payment, let's go back and try to actually open up the payment sheet. Okay, so we can go to any kind of location, find, choose a driver, and click confirm. This time we get an error saying you did not provide an API key. I think that's because we haven't reloaded our application since we added our key, because if you look at it, here we indeed are passing our publishable key. We might also need to fix our schema. So let's make a change to that in our book ride. For the merchant identifier, we can do something like, let's maybe do merchant.uber.com. Doesn't really matter. And then the URL schema has to be the same as you have in your app.json. I think by default, it is set to my app, as you can see right here. So let's leave it like that. And let's reload our application by stopping it from running and then rerunning npx expo start with -c to clear the cache. And press R to reload the application. I'll speed up the process of going through all of these screens. And would you look at that? Right here, we have a beautiful little Stripe payment sheet where you can enter your credit card information, the fake one, of course. You can even scan your card. It is so seamless, and you can click pay. Or we cannot right now. That's because that's our next step. If we go here, the next step is to work on this confirm handler so we can actually initiate and process a payment. So now we have created this sheet, and we have to next figure out what happens after we click the pay button. Next, let's copy this confirm handler functionality, and let's paste it right here on top of initialize payment sheet. This confirm handler will be used as a method on this init payment sheet. So right after the mode, we have the confirm handler, which is equal to confirm handler, which is this function that we just created. Here we had it below, so we can delete this empty part, and now we have the real confirm handler right here. The next step for all of this to work is to create a payment intent. So I can collapse this one, where we collect the payment details, and finally, we are ready to create a payment intent, meaning create the possibility for the user to pay, and that has to happen on the server side. So now they created an app.post route. In our case, we'll be using Expo's API routes. So let's go ahead and copy this and create this route that will create a payment intent. That'll be under app, API, and we can create a new folder called, in parentheses, Stripe. Within it, we can create a new file called create plus API.ts. And within here, we can paste what we just copied. Of course, we'll have to make little tweaks to make it fit our Expo API route setup. So we won't be requiring anything. We will simply be importing Stripe, capital letter, from Stripe. And then we can initialize a new instance of Stripe by saying const Stripe is equal to new Stripe, to which we provide our secret key. So that's going to be process.env dot stripe underscore secret underscore key. And you can add an exclamation mark at the end because we know it'll be there. Now we can remove this Stripe instance and the imports for Express. And the setup for creating API routes in Expo is just a bit different. So we're not immediately saying app.post. Rather, we're saying export async function post, where we get access to a request of a type request. And we can extract the body by saying const body is equal to await request.json. And from here, we extract everything else. We can extract things like the name, the email, and the amount from that body. After we extract them, we'll have to check if a name doesn't exist, or if an email doesn't exist, or if the amount doesn't exist, then we can return a new response of JSON.stringify, where we can add an error that's going to say, please enter a valid email address. And we can also pass a status of 400. That has to go inside of this block right here. Let's make sure we're properly opening and closing everything. I don't think I properly closed this function block right here. If we fix that, we should be good. There we go. Now this is immediately structured in a better way by Prettier and the ESLint. And if we have all of this information about a user, we can start creating our customer by saying let customer, and then we can have a check whether the customer exists. So we can say const does customer exist, which is equal to await stripe dot customers dot list, and we're going to search for a user with that specific email. Next, if a customer does exist, in that case, we can say customer is equal to does customer exist dot data 0. If a customer exists, we're going to get the actual existing customer. So we can say existing customer. From it, we can extract the data, and then dot length is greater than 1. That's how we can check whether the customer exists. Else, if a customer does not exist, we need to create a new Stripe customer by saying const new customer is equal to await stripe.customers.create, and we pass a name and an email. Right within the else, if we have a new customer, we want to set the customer to be equal to that new customer. Now, how did I know to do all of this stuff and not just create the payment intent like the doc said? Well, even though this general collect payment before creating a payment intent page was great, it allows us to do some basic stuff, there is a second documentation page, this one right here, that talks specifically about accepting payments in React Native. And if you scroll down, I think we have implemented a couple of these first points, but one of these is that post request about accepting a payment. And here they talk about creating customers, and then they also talk about creating a payment intent. For now, we have dealt with this part about creating a customer, and now we can copy the rest of the stuff. The link will also be down in the description, where we can create a key for each customer, and then create an entire payment intent and return it to the front end. So let's copy this part from line 8, and let's paste it right below our if for the customer. You'll notice that here we create a key that we attach to a specific customer, and then we create a payment intent using stripe.paymentintent.create, and here we need to specify the amount we're trying to charge the user. In this case, notice that I'm passing the amount as part of the body. So what we can do is, instead of using this default $10.99 price, we can instead run the parse int of the amount and then multiply that by 100, because all the payments in here are in cents. So to get to the real amount, we have to multiply it by 100. We can change the currency to USD for American dollars. We have a customer ID, and then they also enable something of automatic payment methods, which is very cool, and we can set that to true. But in this case, just to make it work, we'll have to allow redirects and set to never. This is something that I found works best with React Native applications. And finally, we have to return not res.json, but rather a new response that looks like this. And then we have to first stringify it. So json.stringify, and then we have this entire object. So let's fix that. There we go. We're passing the payment intent. In this case, we can send out the entire payment intent and the entire key. So I will just leave it like this: payment intent, the key, and then the customer ID. And I don't believe we have to send the publishable key back because we already have it on the front-end side. So I will remove this part from here. And this is it. This is our backend function to create a payment intent. It is lengthy, but it is mostly boilerplate code coming from Stripe. That now allows us to come back to the payment and implement it. Specifically, it'll happen in the confirm handler. We're getting three things as the params here: the payment method, the should save payment method, which we will not need to use, so I can just rename it to an underscore. That's kind of a good practice if you're not using some of the parameters. And then we have to make a request to our own server. And Stripe was kind enough to already give us an example of how we can do that. In our case, we'll do it like this. I'll say const. I'll destructure the payment intent and the customer. Remember, this is just what we're sending from the backend, or you can call it Expo API route, and say await fetch API, and we're gonna go to /API in parentheses, /Stripe in parentheses, /create, the route that we just created. We can pass additional options to it, such as a method of post headers equal to an object where the content type is set to application JSON. And most importantly, we need to pass over the body by running json.stringify and passing in a name of the person who is buying. That's going to be equal to a full name in this case, which we can get from the props into the payment function. So before we add this part right here, let's pass some props into the payment function from the book ride. First things first, right at the top of the book ride, we'll need to get some information about the user. And we can do that easily with Clerk by saying const destructure the user is equal to use user. How convenient. Now, if we go down, we can pass all of the user-related information to the payment, so we know who is making the actual payment. We can pass things like full name is equal to user ? Full name, and we can end each one of these in exclamation marks because Clerk is not sure they're going to be there depending on different use cases, but we know that it will indeed be there, so we can tell TypeScript that. We can do the same thing for the email by saying user ? email addresses 0 .email address exclamation mark. And then we need to pass the amount of the drive. So that's going to be driver details $price. Next, we need the driver ID as well, which is going to be driver details $.id. And finally, ride time, which is going to be equal to driver details $.time. And now we can go into the payment and we can accept all of these props. Let's do it right away by getting the full name, the email, the amount, the driver ID, and the ride time. And all of these will be of a type payment props coming from types. Now that we have these, we can send more information to the server by saying that the name will be equal to either the full name or email.split. And we can split it by the email sign and take the first part. We can then pass over the email, which will be equal to email, the amount, which will be equal to amount, and the payment method ID, which is going to be equal to payment method .id. Again, WebStorm nicely found that I have a typo. It was supposed to be payment. Now that we have this, we basically have everything we need to get a payment intent, or rather to create a payment intent on the backend and pass it over back to us on the front end. So right here below, we can make a check and see if payment intent dot client underscore secret. So are we getting any secret from here? If we are, then we can actually make a payment based on the payment intent that we created. And to make that happen, we'll have to create a second API route for payments. So let's create a new file within the Stripe folder, and let's call it pay plus API.ts. And it'll start similar to create. We can copy the import of Stripe. We can copy the part where we initialize Stripe, where we export an async function, and where we extract some data from the body. Heck, this part as well will be the same, where we check whether we have all the necessary info. So let's copy these initial lines and paste them into the payment API and make sure to properly close everything. Of course, we'll have to make some changes. Instead of getting the name, email, and amount in this case, we're getting some more payment related stuff, such as the payment underscore method underscore ID, the payment underscore intent underscore ID, and the customer underscore ID. And now we can make a check whether all of these indeed exist. And if they don't exist, we can say something like missing required payment information. Great. But if we have all of that payment information below this if, we can finally create a new payment method by saying const payment method is equal to await stripe.paymentmethods dot attach. So which payment method we want to attach? Well, the one that we have the ID for. So payment method ID. And which customer is paying for that? Well, we can provide that in the second parameter, customer is equal to customer underscore ID. That's going to look something like this. And below it, we can get the result of the payment by saying const result is equal to await stripe.paymentintents.confirm, to which we can pass the payment intent ID, and we can pass the payment method as the second option inside of curly braces, where we can say payment method is of a type payment method.id. Finally, once we have the result, we can send it over to the front end by returning a new response within which we have a JSON stringify with a success that says true, a message that says something like payment confirmed successfully, and a result of that payment equal to result. Of course, if something goes wrong, then we have to have a catch. So I'll copy this entire block of code and put it within a try and catch block. So this part goes into try, and in the catch where we get the error, we can console log the error, and we can also return a new response that has a JSON stringify within it that has the property of error equal to error and a status equal to 500, pointing to a server error. So now with these two API routes, first of all, we have created a payment intent allowing our user to get the possibility to pay. And then with the second API route, we are actually allowing the user to pay based on the provided payment intent. So going back to the payment, we can now receive that response on the front-end side by saying const destructure the result and say is equal to await fetch API in parentheses API / in parentheses stripe / pay. It'll have similar properties as before, such as a method of post, headers equal to content type of application JSON, and a body, which will be a JSON.stringify to which we need to pass all of this important information from the payment intent, such as the payment underscore method underscore ID equal to payment method.id, a payment underscore intent underscore ID equal to payment intent.id. And what else do we need? I think it was gonna be, let's see, customer ID. So we can also pass the customer underscore ID is equal to customer, because that is actually the ID. And now that that is successful, we can do the last thing necessary, which is to create a new ride. That means hooking up our driver to our rider and making sure that the rider has actually paid, and then we can create a new ongoing ride. We're not gonna test the payments yet before we can create a new ride in the database. So let's do that next by checking if result.client_secret. If it exists, that means that everything is ready to create a ride. And we have to be one scope above right here to have access to this result. Here, we want to make a call to a new API route of ride/create. So let me close these existing routes and let's create one route, but this time that will not be just for Stripe. It'll be for creating our own rides. We can do that by creating a new folder within our API folder that's going to be called ride. Within the ride, we can create a new file called create plus API.ts. And within here, we have to connect to the Neon database and create a new record in the database. Most of this file will be just a single SQL mutation. So under snippets in the GitHub README, you can find the API ride create plus API, and you can copy it from here and paste it right there. You'll notice that this is just a single try and catch block. In the catch, we're handling the error, and in the try, we are getting all the information from the body, we are destructuring it, we're checking if it all exists, and then if it does, we're simply creating a new SQL query where we define the fields and we define the values that we're passing into that, and finally returning this newly created ride back to us. Again, there is about 70 lines of code just because we had to write pure SQL syntax. Nowadays, there's also tools like Drizzle or Prisma, so if you'd like me to see use that more often, just let me know. But sometimes it's good to understand how native SQL works because these ORM tools all use SQL behind the scenes. And as I promised, if you want to learn more about SQL and also ORMs like Prisma, I would highly recommend checking out this course that we created, which is for now completely free for you. So here you can learn a bit more about different SQL mutations, such as inserting data, which is exactly what we're doing in this one. It teaches you how you can insert different properties. Take a look at this. It is exactly what we're doing. Insert into user's table, name and email, and then you provide the values for that name and email. Check this out. Insert into rides, origin address, and then you provide the value for the origin address. Pretty straightforward, but it is a bit lengthy, so I decided to provide it here for you. There's also going to be just one more similar file to this one more API route, where instead of creating something, we'll be fetching all of these things from the rides. So that's also going to be lengthy. So let's just quickly create it. It's going to be under ride, create a new file. It'll be a dynamic route based on the ID. So it's going to be square brackets ID plus API.ts. And you can find this file in the GitHub README down below, so you can paste it as well. As you can see, instead of inserting, in this case, we're simply selecting all of the properties that we want to get from this request that we're making. Great. Now we can go back to payment and we can call this API request that creates a new ride. But before that, we'll have to get away from our mock drivers and we'll have to create real drivers in the database. Remember, right now, I think in the map, right, we have some fake drivers right here. Now, what we could do is manually create all of these driver accounts, but we can also go to the SQL editor and we can run an SQL mutation to create all of these drivers. So in this GitHub snippets README, you can see the create drivers table SQL, which you can copy and then paste right here to create a table. It says connected, there we go, it succeeded. And then the second thing we can do is seed the database with the drivers. Seed is a word that is used when you want to quickly populate the database with some data. So we can copy this command and paste it right here, where we're going to insert some drivers right here. We can click run, and it has been successful. We can verify if we go into tables. You should be able to see a drivers table with 4 different drivers. Great. So now we can remove these fake drivers and we can actually fetch real drivers from the database. Let's do just that. We're using those drivers right here in the use effect. And even I added a note right here that we need to remove that. Rather, we have to fetch them for real. And we can do that by first creating an API route that will give us back all of those drivers. So let's do it by creating a new API route in the API folder called driver plus API.ts. And this one we can write ourselves, just so we can see how it is to write some simple SQL queries. We can say export async function get, where we can open up a try and catch block with the error. If something goes wrong, we can just console.log that error. And we can also return a response.json where we send over the error, which is equal to the error message. In the try, we can actually access the NeonDB database by saying const SQL is equal to neon, coming from Neon Database Serverless, to which we need to provide our database URL or our connection string. So let's say process.env.database_URL. It is that simple. And now we can say const response is equal to await SQL. We write a template string and we select everything from drivers. That's it. Give me back all the drivers. And with that, we can return response.json, where we pass over the data, which is equal to response. So now back in the map, we can fetch all of those drivers. Let's do that right away at the top by saying const data, which we can rename to drivers. We also get the loading state and the error states, and that is equal to use fetch. We can specify the type. It'll send back an array of drivers like this. And here we need to specify the URL, which we're calling. That's going to be / in parentheses API / driver. I'm going to minimize this just a bit. I hope you can still see it. And we're basically fetching all the drivers here. So now we can make use of the loading state and the error states by adding something above the map. So we can say if we are loading, or if there is no user latitude, or if there is no user longitude. In that case, we can return a view, we can zoom it in, and within it, we can return an activity indicator with a size of small and a color equal to #000. It looks like that broke my screen share right here. No worries, we'll fix it soon. We have to import the view right at the top, and below we can check if there's an error. But let's make sure to properly close this. I noticed that I'm missing the curly braces here. If there is an error, we can basically have a very similar view to this one. I forgot to add the class names, so let's give it a class names equal to flex, justify dash between, items dash center, and w dash full. This will basically make it appear in the middle. We can duplicate this entire view if there's an error. Of course, let's copy the return as well. And only instead of the activity indicator, we'll show a text that'll say error, and then we can render the actual error message. And we have to import text from React Native. Great. So now we have the error handling, the loading handlers, and we are fetching the drivers. So let's put those drivers to use. Scrolling down, we won't be setting the drivers right here. We'll be setting them somewhere else. In that second place will be a new use effect right below this one. Because now that we have the real drivers, we can also create a path between the writer and the driver so we can show it on the screen. You know that route, the blue line from you and the other person? That's exactly what we'll create. Basically navigation. So let's create a new use effect, and we can have an if statement here. If markers.length is greater than 0, and if destination latitude is not equal to undefined. So we cannot calculate something if we don't have a destination latitude, and if destination longitude as well is not equal to undefined. Or we can just say if it exists, right? So if markers.length and if destination latitude and destination longitude, in that case, we can call a special utility function called calculate driver times. that's going to look a bit like this. And to it, we have to pass a couple of prompts. We need to pass all of the markers, which we want to show on the screen, which are basically the cars, the user's current longitude, the user's current latitude, and the destination latitude, as well as a destination longitude. That function is an async function, so we can call a .then on it, which will give us access to all of the drivers. And now, once we get that, we can set drivers to be drivers as marker data array. So this is to make sure that the map understands that the drivers are indeed appearing on the screen. And we can recall this function whenever the markers change, when the destination latitude changes, or when the destination longitude changes as well. So now let's give it a shot. I will close this sheet and I'll say that I want to go, let's say somewhere near in San Francisco. And first of all, don't forget when you make a lot of changes, reload the entire application. So I'll stop it from running and I'll rerun it one more time with the -C tab and then press R to reload the entire application. There we go. Oh, this clerk warning just reminded me that we need to implement the OAuth still. So that's something that we'll do very soon. But now you can see different drivers on the screen as you were able to see before. But now if we go, let's say we are in the lower Pacific Heights right now. If we want to go to this nice park, we can go to Scott Street. So let's do Scott Street. And that's in San Francisco. You can see that we have San Francisco and then Scott Street, and we can click Find Now. And this will open up the different drivers. We can select one of those drivers, and these now are real drivers. You can see that they changed since the last time that we had the drivers. Now they're coming from the database. We might need to do some work to properly show the actual distance in minutes. So let me do that. I think this is in the driver card where we have the minutes right here. Let's see if I can find it. This is the price. And right next to the price, we have the time. We can use the parse integer, I believe, to make this work. And now we can see 4 minutes, 3 minutes, and more. That's good. And it looks like the time needs to be a string. So I can easily convert this into a string by wrapping it into a template string like this. Great. And it still works. So now we can choose a different driver, and you can see that on the screen, the driver that you choose becomes green. So you can see how they're changing colors right here. So now if I choose, let's go with David. He seems to be one of the cheapest ones and the closest to us. Oh no, no way. Looks like Michael drives a nice yellow car, $2 and 2 minutes away. Let's go with that one. And I'll click select. Now we can see all the information about Michael. Looks like we need to do the same thing for the time. So let me copy this entire thing. Go to the ride information. So that is, I believe, under pickup time in the book ride. Yes. And we just need to wrap this properly. So it's driver details.time. Let's add it here. Driver details.time. And we can remove this mock number. Let's make sure to close it properly and save it. And now it says 4 minutes. Nice. But if I collapse it, I'm still not seeing the path from my location to where I want to go. So let's head over to the map and let's look into the function that has something to do with the drivers. This one is setting the driver's car locations. And I believe we have to add some more dependencies to it. You can see even our WebStorm is complaining that it needs further dependencies. Those are going to be the user latitude and the user longitude. So whenever those change, we can also recall this use effect. But that's not the problem. The real solution lies right here in the map.jsx. Currently, we have just the map view and we have the markers, but we have to make a connection from our current initial user location to the destination location. So right within the map, below these 3 parentheses, we can check whether we have access to the destination latitude and destination longitude. And if we have, then we can return a React fragment, or should I say React Native fragment, that'll show another marker, which is going to be the marker for the destination. Let's give it a key so we can differentiate it from the others, such as destination. Let's give it some coordinates to show it on the map. We need to pass it the latitude, which is going to be equal to, you can guess it, destination latitude, and the longitude, which is going to be equal to, guess it, destination longitude. We can also pass it a title, which is going to be equal to destination. So let's do just that, destination. And we can give it an image, which is going to be a typical icons.pin. And now, check this out. I can actually see that I wanted to go to Scott Street. And would you look at that? There's some trees there. That seems like a nice place to take a walk around. And we can see the pin on there. On your screen, you should also be able to see a pin near your exact location. So you can see pin from and to. But now, let's create directions from you to the pin. We can do that by installing a new package. So let's open up a new terminal and say npm install react-native-maps-directions. And that's going to allow us to, below the marker, put this new map view directions. We of course need to import it at the top by saying import map view directions from React Native Maps directions. That is great. And now we need to give it additional information so it knows what to show. We of course have to give it an origin, which is going to be our user's latitude. That's going to be user latitude. And we have to give it longitude, which is going to be our current user's longitude. Next, we have to give it the destination, which is going to be similar to what we have here. We can copy the coordinates of the pin where we want to go. Latitude is destination latitude, and the longitude is the destination longitude. To it, we need to provide the API key, and that key is coming from envs. So we can say process.env dot, and let's check the exact name in our .envs. It's going to be expo public Google API key. So we can copy it, paste it here. Let's make sure to properly close this destination. And finally, below the API key, we can also choose our stroke color. So the color of the path. That can be a bluish color of something like hash 0286FF and a stroke width of about 2. If we save this, we have to make sure that we're properly enclosing it. I think we have 2 extra ending braces and we're missing an equal sign right here. And would you look at that? We now have a complete path through the streets from our current location on the map to the destination location. How cool is that? If you want to, you can change the color and you can make it a bit wider. That's totally okay too. There we go. This is perfect. And now we can even see, maybe we can go for this driver right here, for David instead of Michael. So let's go back. Let's choose David. There we go. That rider is now green. And we can select a ride and see where we want to go from our location to the destination location. Great. Now, where were we? I think we were on the payments where we want to confirm the ride. And just before we actually pay it, we wanted to create a ride, which we now actually can do because we have real drivers in the database. We have created a real rider when we created our account. So the only thing we have to do is to create a server action that will connect it to and book us a ride. So let's head over to our API calls and check out our ride create. This is the one where we're simply getting all the fields we collected so far and then inserting it into the database. We can call it from the front end now, or should I say from our device screen. We can do that by saying await fetch API, to which we can pass the URL of / in parentheses API / ride / create. As additional options, we can pass a method equal to post. We can pass headers equal to content type application JSON, and we can pass the body. Now keep in mind, you know that in the actual API request, we are getting a lot of things through the body. So we have to do the same thing here. JSON.stringify within an object. And now we have to pass all of the info we have collected so far. The user info, the destination info, everything. So let's say origin address, meaning where we're going from, is going to be equal to user address. And this user address we can get from the location store. So right at the top, we can get all of this great information from the location store by saying const something is equal to use location store. And right here, we can get the user address. We can get the user longitude, user latitude, destination latitude, destination address, and destination longitude. Now, in an ideal world, we wouldn't need to destructure all of these properties and then now again form them properly. Ideally, you would be using the same exact names on both the front end and the back end. But sometimes it's not like that. Sometimes Stripe uses underscores or kebab case and you're using camel case. So it's always better to destructure them and make sure that you're passing the exact right names of the variables. On the backend, right here, if we go to create ride or create ride API, this one right here, you can notice that we're inserting origin underscore address and not origin address with a capital A right here. So for that reason, we have to properly spell it here as well. Origin address is equal to user address. Let's continue with passing other properties as well, such as the destination address, but make sure to use the snake case right here, is equal to destination address in camel case. We can get the origin latitude equal to user latitude and origin longitude equal to user longitude. We can get the destination latitude equal to destination latitude. Make sure to put that in snake case as well. Snake case is the recommended case for Postgres databases. That's why we're doing this. And we can do destination longitude equal to destination longitude. We can get the ride underscore time, which is equal to ride time dot to fixed 0. We can do fare underscore price to be equal to parse int. We take the amount and we multiply it by 100 to get into cents, as that's how Stripe processes payments. We can set the payment status to be equal to paid, because this is after we actually confirm that the payment went through by Stripe. We need to know which driver processed the payment, and we need to know the user ID that accepted that ride. And this user ID is coming from useAuth by Clerk, so we can get it right here at the top by destructuring the user ID coming from useAuth from Clerk. Great. So now we have everything we need that we're passing to create a ride. And finally, we can call the callback of the successful intent creation. So that's intent creation callback, to which we need to pass our client secret, which is equal to result.client underscore secret. You can see that Stripe uses this snake case as well. Finally, this entire time, we have been within the confirm handler, which is only one small part of the intent configuration right here, as you can see. Now, right below the intent configuration, we can enter the return URL, which is going to be my app ://book-ride. So this is where we want to go back to after we complete the payment. And if there's an error, we can just console.log the error. Now let's see if we have some warnings or errors remaining. We have one right here with the client secret. I think this is something that we copied way back from Stripe, but we don't need it anymore as we have implemented it right here above, where we're basically passing the client secret into the intent creation callback. So we can remove this part right here. Do we have any other warnings or errors? We can see that the confirm handler is complaining a bit about the types that we're passing into it. It's saying that the payment method shouldn't have a type any. It seems that we don't have any types for the payment method, intent creation callback, and that's why it's complaining right here. Those can be easily fixed if you collapse the function, copy the entire function block, and paste it right here where it's being used, like this. And then you can remove this original function. because now we're just using it automatically within Stripe. And a pretty cool thing is now that it is within the intent payment sheet, it actually knows everything about the payment method, intent creation callback, as it infers it from the types above. That's cool. So with that in mind, our initialize payment sheet is finally done with the confirm handler, the return URL, everything, the whole deal. And it took a bit more time, and that's because at the same time, we were setting up our own code functionality, such as getting the riders, the drivers, the ride creation, and so much more. But now all of that should be done. And before we go ahead and test it out, just bear with me, there is one more thing we have to do, and that is create a success modal, okay? Remember, we just have this one unused variable, just a single one. I can delete these ones just so we don't have warnings, but there's just a single unused variable called success. We wouldn't want to leave that success to hang there on its own, right? So we can use it within the modal. If we're successful, let's reward our great work by creating a React Native modal and say is visible only if success. How convenient. On backdrop press, so once we exit out of it, on backdrop press, so once we click outside of it, we simply want to set the success to false. So set success to false, which will hide the modal, and then we can go on with our day and book some additional rides or track our existing ride. So what are we going to show within this React Native modal? It can be a view with a class name equal to flex, flex-call, items-center, justify-center, background of white, padding of 7, and rounded-2XL. Within it, we can render a check image. So let's get the image from React Native with a source equal to images dot check and a class name of W of 28, H of 28, and a margin top of 5. Now, how can we show this success modal right here? Well, we can show it by turning the success to true by default, just for the time being, and closing this payment sheet modal and going all the way back to somewhere else. So let's do just that. And I think this is our modal, but something seems to be breaking at the moment. Oh, maybe because we forgot to import the view from React Native. Once we bring it back, we'll have to one more time test it out. Oh, there we go. You can see this. Even on the home screen, we can see the last path that we've drawn out. This would be a huge path from California all the way to Tennessee. I recently saw a YouTube video where a guy ordered the longest possible Uber ride. It was spanning across multiple European countries, I think. Pretty cool. So let's go over and select a new location. Maybe we want to go to New York. And I'll select a driver and the ride. And there we go. Now we can see this small success thing. Below the image, let's render a piece of text and make sure to import it from React Native. It can say something like booking placed successfully, or maybe something simpler like ride booked. We can give it a class name of text-2XL, text-center, font-Jakarta bold with a margin top of 5 to divide it a bit from the icon. Below it, we can render another piece of text that'll have a class name equal to text-md, text-general-200, font-Jakarta medium, text-center, and margin top of 3. And it can say something like, thank you for your booking. Your reservation has been placed. Please proceed with your trip. There we go. That's looking nice. And below it, we can render a custom button. This button will have a title of back home. And on press, we want to have a callback function that sets the success to false once again, as well as uses the router.push Okay, so I'm gonna put this in multiple lines so that after we set the success, we can also use the router from expo router dot push and push to /root /tabs /home. We haven't been there in quite some time. There we go. And we want to style it a bit by giving it a class name equal to margin top of 5. Beautiful. What do you say that we manually turn the success back over to false and try to book an actual ride for the first time in this entire course? Let's do it. I'll click confirm ride from San Francisco to New York for $1,200 and 42 hours in pickup time, and I'll click confirm ride. There's one mistake that I can notice here, and that is that the Stripe button still says 10 bucks. You definitely wouldn't want to make this mistake in your real app because people would soon enough make use of it. So we have to figure out where we're passing the amount to Stripe, and it is right here in the intent configuration. So that is the last part that is remaining for us to do. We can change the merchant display name to something like Ride Incorporated. The amount will be set to parse int amount times 100 to get to cents, and the currency will be USD. If I save this and close the sheet and reopen it, you can see that now the price is correct. So you can enter your card number. For Stripe test mode, it is 424242, and you can keep typing that until the end. You can do the same thing for the months and years and the CVC, but make sure that they're valid months and years. And you can now click pay. Don't worry, no money will be taken from your accounts. You haven't connected your own details with this. This is just test info. So I'll click pay. It says processing, and it seems to have went through. Ride booked. Back home. This is amazing. We can track our location, and even though these recent rides are fake, now our next step will be to add a real recent ride right here so we can check it out and see how that is going. Great. This means that the main primary flow of our Uber application has been completed. A user can create their account, search for a location where they want to go, choose their driver, book a ride, and make a payment. Beautiful work. And if you came to this part of the video, leave a comment down below and tell me, I'm here. I completed the main flow. Not many will get there, so great job. Now that we have that out of the way, as I said, we can focus on replacing the mock recent rides with the real ones by fetching them from the database. And then after that, we'll quickly fix the Google OAuth, and then we can focus on the rest of these pages. Once again, great work. I'm super proud of you. To remove our mock rides and instead of them use the real ones, we can head over to our homepage. We can scroll a bit up, and right here, you can see that we have fake recent rides. Instead of those, what do you say that we fetch the real ones? But to make that happen, we have to tap into this ride ID functionality, which is going to fetch the specific rides for our own user account and bring us back all the details. So let's go to the home and let's say const data, which we can rename to recent rides. We can also get the loading from there, and that's going to be equal to use fetch to the URL /API inside of parentheses /ride / and then we have to do a dynamic template string of user $.id. First, let's turn this string into a template string. There we go. And now let's actually get the user from the use user. And we can remove this fake loading at the top. Now it says no recent rides, as you can see right here. And I think I know why. We created the tables for drivers and users, but before creating a ride, we didn't create a table for the rides. So right here under snippets, you have the create rides table SQL query, which we can execute in our SQL editor and run. There we go. It successfully created the table. And since the table wasn't created before, right now it doesn't exist. So let's go through the entire application flow one more time and see if the ride will get created. Okay, I came to the end screen in the flow. I can enter my credit card details and click pay. It's processing. It's successful. And if I go back home, we can now see 1 recent rides from San Francisco to Scranton. And it even gives us a little screenshot of the location where we're going to. Great. So now we can remove this recent rides from here as we're no longer using them. And now all of the data in our application is real. What we can do next is press the logout button at the top right. We haven't seen our onboarding screens in quite some time, and I'm pressing it, but it doesn't seem to be working. Let's see what's up with that button. That is in a place where it says welcome, and then we have the name. So that's gonna be right here in a stack screen under home. And here we're handling the sign out functionality where you can see that it's completely empty. So we have to implement it. The only thing that it'll do is it'll call the sign out function, which is gonna come from use auth from Clerk. So we can say const sign out is equal to use auth coming from Clerk, and then we can call it, and we can use the router dot replace to go to /auth in parentheses /sign in. Now let's try to click the button one more time. And this time we are redirected to the sign in page. Now, if I click login with Google, nothing will happen. Same thing if we go to sign up, it's not doing anything. That's because we have implemented only the email authentication, and now we have to do OAuth. Clerk makes that super simple with their documentation page on building a custom flow for authenticating with OAuth connections. So you can just search the docs for this page. It's under custom flows OAuth connections. And then you need to switch it from Next.js to Expo. We can skip this Expo linking part, skip the browser part as well. And the only thing we need is this start OAuth flow with the OAuth strategy and then the on-press functionality, this part right here. So let's copy that, go back to the code to our OAuth component where we have our custom button, and we can paste what we just copied. I'll paste it over this function. I'll rename the on-press to handle Google sign in, and I will override our on-press on the button click to handle Google sign in, and we can just slightly modify this. First of all, let's import use OAuth from Clerk Expo with a strategy of Google OAuth. Next, import use callback from React. After that, we can start this OAuth flow, and we can slightly modify this part right here. So I'll close it just so we have a clean slate, and I'll say const result is equal to await, so we have to make this function async, and Google OAuth like this, to which we then pass the start OAuth flow function. But the question is, where's this Google OAuth coming from? This Google OAuth will be a utility function which we can create. It'll be under lib auth, and then here we have the token cache. But now we'll create an additional function, export const Google OAuth, which is going to be an async function that accepts the start OAuth flow of a type any for now. And we can open up a new try and catch block. In the catch, we of course have the error, and in the try, we'll copy this part about linking. So here we want to extract this linking part and this if and else that we removed previously, and we can paste it right here. That's gonna check whether we have a created session ID and whether we can sign up. And we can also make a user active. For that, we do need the linking. So remember what they say right here, we need to install Expo linking. This will allow us to link our application to the Google sign-in modal that pops up, and then it allows users to go back to your own application. So let's run npm install Expo linking, and let's make sure to import it at the top by saying import everything as linking from Expo linking. And then we're creating a new URL which we want to redirect to. It is /root in parentheses /tabs /home. Next, we're checking if it's a sign up or a sign in. Rather, has the user created an account before? If they have created an account, then we're doing sign in, else we're doing sign up. So everything within this if will be called both on the sign in and the sign up. So let me show you what we can do. We can say if setActive exists, then we can await setActive, and this is basically adding the user session. But now, only if it's sign up, so if sign up dot created user ID, then we want to also create a database user. So we can say await fetch API with a URL of / in parentheses API / user. The method will be set to post, and the body will be JSON.stringify, where we can pass a name, which is a template string of signup.firstname, as well as signup.lastname. Let's fix this typo. We can also pass the email equal to signup.email, and we can pass the clerk ID equal to signup.createdUserID. And this creates a user in the database. We want to go below this 2 sets of double parentheses and below one more to return an object that's going to say success is true. We can also pass a code of success and pass a message of you have successfully authenticated. Outside of all of these braces, we can return success to false, because if we reach this point, something is not good, with a message equal to an error occurred. Finally, in the catch, console log the error and return success false and a message that an error has occurred. So I can paste this, and maybe this time we can just do error (errors 0 (long message). This will give us the full error information. And let's make the error of a type any right here. Great. So now we are authenticating users using Google OAuth, and we're creating an account when they sign up. So let's import this Google OAuth from libauth, and we're getting the result. If the result.code is triple equal to session_exists, then we can alert, coming from React Native, .alert success, but add a message of session exists, redirecting to home page. And of course, we'll have to do a router.push / in parentheses root / in parentheses tabs / home. Outside of that if, we can check if result.success. If that is the case, we can say success, else we can say error. And that can be within the alert. So we don't actually need an if. So alert.alert, and then we just show that title. And as the second parameter, we render the result.message. If we catch something, then we can just do a console.error. Great. I think this is it. We already have the UI. Now we implemented the logic, and we can give it a shot. Let's go through the onboarding. And let's click login with Google. I noticed a typo there. That was supposed to be with right here. There we go. And let me click the button. Expo wants to use google.com to sign in. Yes, let's allow it. I chose my account and I'll click continue. And it didn't redirect. I think I know why. I misspelled exists right here. So session exists. Okay, I can fix this typo on success as well. And if we go back to auth, in the return right here, so this is at the bottom of our Google OAuth function, we also need to pass the code. And the code will be success if you're successful, or here at the bottom in the catch, the code will be equal to error.code. Now, this code will sometimes correspond to session_exists. Even though it's not really an error, I mean, technically it is because we're trying to sign up to an account that exists. But still, in that case, we're going to say success, redirecting to homepage. And one more thing I noticed here in auth, instead of saying email address, I just used email right here, which is wrong. So this also could have broken the application. So if we fix that, we can give it one more shot. I'll click login with Google, continue. Next, I'll say continue one more time. and we still didn't get redirected. But if I open up the terminal, I can see a console log that I added before. And if I press R for reload, you can see that we are within our application. And now it says welcome Adrian, which means that we're successfully logged in with our real account. And we have one recent ride. Beautiful. I'm still not sure why this OAuth is not redirecting. This is definitely something we need to come back to later on. But for now, let's quickly implement the all rides screen, as it's gonna be super simple. It's just gonna be a collection of recent rides. And we're showing that already on the home, so it's gonna be super simple to show it here as well. We can head over to our rides page, which is right here under tabs, and within it, we can render a flat list, similar to the one that we have in the home. So let's quickly go to the home, let's find our flat list, and let's copy the entire thing, just until the end of the flat list. And we can put it right here within the save area view. Make sure to import flat list right here from React Native and save it. Of course, there's gonna be some fixes that we have to do to make it work. For example, we have to also fetch the recent rides, same as we're doing in the home. So right here at the top, here we're fetching the recent rides, and here we're fetching the user. So we can copy those two things and add them to the rides. Use user is coming from Clerk Expo. And this is pretty cool. When I copy things from the other file, WebStorm actually copies the imports for me, which is amazing. Right now, if we go to all rides, it kind of breaks, and that's because we don't need all of this data here. So let's clean it up. Instead of slicing the recent rides, we can show all the recent rides. Next, under list empty component, we can more or less leave it the same. And under the header, it's gonna be much simpler than what we have here. We don't have to have the sign out button, nor the Google text input. So we can basically remove everything from here and just keep one single piece of text that's gonna say all rides. And we can give it a class name equal to text-2XL, font-Jakarta, bold, and we can save it. And right here, before the use fetch, what we're expecting to get back is an array of rides, which are coming from types. So we can define the ride right here. That way, Flatlist knows what it is accepting. And believe it or not, since we're reusing a lot of the components, we don't need these imports too. And it was super simple to just recreate this all rides list. Right now, it is just one, but once we book some more, they'll all be shown here. We can also add a margin Y of 5 right here to divide it a bit from top and bottom. Beautiful. And I couldn't proceed further without fixing this redirect on the Google button. So while I took a bit of a break from recording, I went ahead and tested it out a bit further, and I think I've came to a conclusion. First of all, we can go to the Google text input. And for some reason, Android devices have a problem when a font weight is typed in as a number. So I went ahead and just wrapped it in a string. Not a big deal, but just something that needed to be done for the Android devices. This won't fix the redirect on its own. But now we can head over to OAuth right here. And so far, we've been only redirecting if a session already exists. But here, I can add an OR and say if result.code is triple equal to success. In that case, we also want to redirect. We don't need to show the success message. And we can also remove this bottom alert right here. I thought we didn't need this because Google in the auth should do the actual redirection here to the home. But for some reason it wasn't doing it, so maybe we need to do it manually like this, which is okay. Also, don't forget that in the auth, this right here has to be email address, not just email. And while I was further testing it, I experienced some additional issues, such as this error saying too many files open, and then my Expo server would crash. Basically, there is a solution, and it is to run brew install Watchman on macOS. At least it fixes it for Mac. Very weird issue, but it worked for me. Another even weirder issue is that I got another error saying use process and then work with async plugins for some reason. And a solution to that is to downgrade Tailwind to 3.3.2 instead of Carrot 3.3.2. So if you're having some issues, you can go to package.json and you can find Tailwind CSS remove this caret from here, then you'll have to clear the expo folder, clear the node modules and delete it, and also delete the package log.json. Rerun npmi, and then start the expo server again. That should fix it. There's many of these very small but weird issues, but thankfully, I've managed to find solutions to them. What you can do next, just to make sure we're on the same page, is delete all Clerk users. And you can delete all Neon users as well. If you have any rides, delete those too, just so we have a clean slate. Once you do that, start the application again. And while we're here, we can try to find a way to suppress this Clerk warning at the bottom. Since we know that everything works, I can quickly go into the main layout. That's the app layout right here. And right at the top, we can write something like this. Import logbox from React Native. And then we can say logbox.ignore logs patterns warning. And then that cleans it up. So now we have a nice clean onboarding and we can get started. I'll log in with Google. I'll click continue and we got redirected. That is great. I know we changed a lot of things. So if this didn't work for you, don't worry. It happens. It is possible. Feel free to reach out on Discord or check out the description where we can mention some of the most common issues that people have experienced and solutions to them. If you cannot find a frequently asked question, then definitely feel free to ask on Discord. The link is down in the description. What I would highly recommend is also comparing your files to the final files in the GitHub repository. It's possible that you have a typo here or there, or that the route is misspelled or something. Even though we have linters and TypeScript and all the other great things, mistakes happen, which is okay. But for me, it works right now. So let's give it another shot by going over the entire applications process. We can select a ride. Let's give James an opportunity now. There we go. This looks good. We can confirm the ride and I can make a payment. I'll enter my test details and click pay. It's processing. We got a success and we can go back home where we can see our recent rides. This is working beautifully for me. If I reload, I can still see the Clerk warning here. So I think we can quickly go back to layout and change this from warning to Clerk. This way, Clerk's warnings will be suppressed, and make sure to remove the 3 dots as well. So now if we reload, you can see it is gone and we can continue exploring our application by going to the ride screen and we can see our recent ride. There's only one right here, which is amazing. So we have the home and we have tested the entire procedure of the flow of creating the rides. And now we can also super simply just log in, press continue, and we are in. Now, as an exercise, I have left 2 different screens for you. One is the profile. It looks something like this. You have a profile photo, your name, email, maybe even an email status, but it is not necessary. And then maybe even a phone number. It is optional. You should be able to reuse the input that we have created so far to quickly spin up this screen. And these fields don't have to be editable, so they can be read-only. If you want to implement it on your own, feel free to pause this video and give it a shot. The code for that will go inside of the profile page. And you can use the input field component we have created so far. So pause this video if you want to implement it on your own, or if not, if you really want to be done with this great application, since the primary flow is now done, I'll provide you with the code. It's going to be in the GitHub README where all of the other code pieces have been, and you can simply paste it right here. It'll look something like this. You get your very simple image, which we can pull from Clerk, especially if you logged in using Google. We get your first name and last name, which we show in uneditable input fields. And then we can show the email and the phone. This is it. Very simple. Now, when it comes to messaging, this is something that I left completely open-ended. In this video, I'll just provide you with this illustration, which is just gonna say no messages yet. So this project will not include messaging. But if you really wanna bring this project to another level, you can go ahead and implement an entire messaging system. use some kind of a package or a library or a service that will allow you to do that in a simpler way. If you do decide to implement it, well, we are on Instagram, so you can simply tag us and I'll gladly reshare your work. You can also tag me on Twitter, where we're sharing a lot of the great work that you guys do. For example, I shared one 14 hours ago by Mahed, and we are on LinkedIn too. So if you create something cool, I'll gladly share your work. If not, no worries, I'll still provide you with a way to finish this great project off so you can share it with your friends and potential employers. You can do that by going to the chat component and then copy and paste the chat component from the GitHub README and paste it here. As you can notice, it is a very simple safe area view where we have an image and some text. So if we head over to that screen, this is how it looks like. With that in mind, even though it seems like we only have a couple of screens, actually there's so many more. Don't forget about our great onboarding that we saw at the start, and that you can get to if you reload your application. This looks great. Next, we have a beautiful authentication, login, and sign up forms, where we can easily log into our account. We have a super responsive map where we can see everything on the screen, as well as the recent rides. And what do you say that we give it one more shot? Let's go to Palo Alto, visit Steve Jobs. We can choose our rider. There we go. This is looking great. We can verify our ride and click confirm. And for one last time, we can pay just to make sure that our entire app is working seamlessly and it's successful. We can go back home to see it in real time, or go to all rides where we can also see this new ride. It is a very comprehensive app with a lot of moving pieces. So I'm amazed that you came to the end of this video. If you're still here, definitely leave a comment down below and tell me, hey, I finished it. I could have turned this into a paid course, but I decided to release it for free here on YouTube, just so you can learn about WebStorm, which is the new IDE I'll be using in future videos too, Clerk, so you can implement authentication very easily, and Neon, which is my database of choice for all future applications. And now you know how to use all of these great dev tools to implement apps such as the mighty Uber clone. And if you haven't already, definitely download the Ultimate React Native Guide, just so you have a written guide by your side when you continue your React Native journey past this video. And here on the first page, I tell you a bit more about something great that's coming. I have started to develop the Ultimate React Native course. If you liked what we have done in this video, and you obviously have since you're at the end of this video, then you're gonna love what's coming in this pro course. If you download the guide, I'll keep you updated. With that in mind, thank you so much for watching and coming to the end of this video. Great job on building the Uber clone, and I'll see you in the next one. Have a wonderful day.